Hello there, and welcome to Just About Earth, where curiosity gets cozy and science drifts gently between wakefulness and wonder. Tonight, we're travelling far back in time to a moment when the world itself nearly ended. Not through war or comet or some silent human mistake, but through the raw, breathing power of the planet beneath us. You and I are alive because Earth survived a single night of fury that changed everything. So before we begin, take a breath, settle in. Let your shoulders drop a little, maybe find that comfortable position where your thoughts can slow down. And tell me, where are you listening from tonight? Somewhere warm, perhaps, or wrapped in blankets while rain taps against your window? It's strange to think that wherever you are, the ground beneath you is built on the quiet remains of volcanoes, each one a story of fire and rebirth. If you find this kind of calm science comforting, a way to learn while you rest, I'd be so grateful if you gave the video a like, maybe even subscribed. It helps this small, sleepy corner of Earth reach others who might need a peaceful way to drift off to. So, tonight, let's go back 74,000 years, before cities, before writing, before history itself had a name. The world was colder then, but alive with movement, glaciers creeping, herds of giant mammals roaming through grasslands, small groups of humans walking along river valleys with stone tools and quiet courage. They had no way of knowing that beneath the island we now call Sumatra, something vast and ancient was stirring, something older than humanity itself. When we think of volcanoes, most of us imagine a mountain, sharp, tall, with glowing lava rolling down its sides. But what lay beneath Sumatra was no ordinary mountain. It was a colossal magma chamber, a reservoir of molten rock buried deep in the Earth's crust, stretching for miles. Over thousands of years it had slowly filled, pressurized, and swelled like the lung of a sleeping giant. The ground above it rose imperceptibly. Lakes shifted. Steam vents appeared where none had been before. The island breathed quietly, steadily, until one day it didn't. Geologists call it the Toba Supereruption. It wasn't just big. It was one of the largest volcanic events in the last 2 million years, an explosion that dwarfed anything humanity has ever witnessed. If Mount St. Helens was a matchstick, Toba was a continent on fire. Imagine an eruption powerful enough to fling more than 2,000 cubic kilometers of ash into the air. Imagine a column of rock and gas rising 40 miles high, breaking through the atmosphere into the edge of space. The explosion would have been heard across half the planet, though few ears were there to hear it. We can only reconstruct it now through evidence scattered in ash layers, ice cores, and the quiet language of geology. But from those traces a picture emerges, one of chaos and silence intertwined. When Toba erupted, the Earth's crust tore open. Entire valleys collapsed inward as magma burst upward with unimaginable force. Rivers of molten rock flowed across Sumatra, carving new landscapes in hours. Ash rained down for weeks. Across South Asia, meters of it blanketed the land, burying forests, choking rivers, and changing the shape of coastlines. For days, the sky would have been a deep, churning grey, flickering with lightning as ash particles collided high above. Temperatures near the eruption site would have soared to impossible extremes. But even thousands of miles away, the world began to dim. Fine volcanic dust, so light it could float on air, spread through the upper atmosphere, reflecting sunlight back into space. The sun's warmth weakened. The planet began to cool. It's a strange thought, isn't it? That something invisible, tiny bits of glass and dust drifting in the sky, could darken the entire Earth. But that's what happens when a supervolcano erupts. The ash doesn't just fall, it lingers. Sulfur dioxide released into the air reacts with water vapour to form aerosols, minute droplets that scatter sunlight and lower global temperatures. Scientists believe that after Toba's eruption, the Earth's average temperature may have dropped by as much as 5 degrees Celsius. In some regions, it might have been even more. For a world already in the grip of an ice age, that was catastrophic. The drop in temperature didn't last for days or months, it lasted for years. Crops didn't exist yet, but plants died back. Forests thinned. Animals that had once thrived in lush environments began to struggle. And somewhere, on the plains of Africa, small groups of humans looked up at a sky that no longer behaved the way it used to. The light was dimmer, the air colder. Night stretched longer than they remembered. When we talk about extinction events, we often think of comets or dinosaurs or sudden ends, but what Toba did was slower, quieter. It tested the endurance of life itself. The world didn't explode and vanish. It simply shivered for a very long time. The ash settled in lakes and oceans, forming layers that would one day become the pages of Earth's diary. For us, the story of Toba is pieced together from those pages, from grains of volcanic glass found in Indian Ocean sediments, from the thin, distinct ash lines buried deep beneath the African savanna, from the ice cores of Greenland that hold microscopic memories of that ancient dust. Each discovery adds a few more words to the record of what nearly happened. In those layers, scientists found something remarkable: a sudden drop in temperature, followed by evidence of droughts, plant die-offs, and shifts in rainfall patterns around the globe. The eruption may have plunged the planet into a volcanic winter that lasted 6 to 10 years. That might not sound long on a geological scale, but for a species living by hunting and gathering, it was a razor's edge. The population of early humans may have fallen to as few as several thousand individuals, a bottleneck that left a genetic fingerprint still visible in us today. Imagine that for a moment. Every person alive now, all 8 billion of us, could trace our ancestry back to a handful of survivors who endured the cold shadow of that eruption. It's not just a story of destruction. It's a story of endurance, of fire and ice, and of how fragile life can be when the Earth decides to turn its face. But even in catastrophe, the planet never truly stops. While ash dimmed the skies, deep beneath the ground, the world continued its slow, invisible movements. Magma cooled and hardened, sealing the caldera that would one day become Lake Toba, now the largest volcanic lake on Earth, stretching across northern Sumatra like a mirror of calm water. It's almost ironic, isn't it, that something born from unimaginable violence now rests in stillness, ringed by green hills and quiet villages. If you stood there today, on the edge of Lake Toba, you might not sense what happened beneath your feet. The surface ripples softly in the breeze. Boats drift by. Fishermen cast their nets in silence. But below that serene blue surface lies the scar of one of Earth's greatest events. The caldera walls, the depth of the lake, the chemical composition of the rocks, all of it whispers of a time when the world was reshaped. Scientists estimate that Toba's eruption released more than 1 billion tons of sulfur into the atmosphere. To put that in perspective, that's thousands of times more than any modern eruption. The energy released was equivalent to millions of atomic bombs detonating at once. And yet, somehow, the Earth found balance again. The ash settled. The climate slowly warmed. Forests regrew. Life adapted. The story of Toba is not only geological but deeply human. It's about memory, not the kind we hold in our minds, but the kind the Earth carries in its rocks and our genes carry in their code. Somewhere in that long silence after the eruption, humanity learned resilience. Our ancestors faced a world where food was scarce, where seasons were unpredictable, where even the sky seemed uncertain, but they endured. They migrated. They adapted. And so, here we are, thousands of generations later, telling their story in the glow of screens, in the safety of homes built on volcanic soil, breathing air that still carries the faint minerals of an Earth that once burned. It's humbling to realize that our comfort, our civilization, our very existence, rests on the edge of a planet that can change everything overnight. When you think about it, volcanoes aren't just destructive, they're also creative. They build land, enrich soil, and release gases that shape our atmosphere. Without them, Earth might never have been habitable. Life, it seems, thrives on a planet that occasionally shakes itself awake. The Toba eruption reminds us that beneath every moment of calm there's movement, deep, slow, unstoppable. It's easy to forget that when we see mountains as permanent, oceans as timeless, but nothing on this planet is truly still. Every rock, every cloud, every breath of air has a story that stretches back to the furnace of the Earth. And maybe that's the quiet truth of it. The Earth doesn't rage against us. It doesn't warn or punish. It simply moves according to its nature, vast, indifferent, magnificent. What we call catastrophe is just one beat in its long, patient rhythm. So tonight, as you listen, remember that you're part of that rhythm. The ground beneath you, though solid, is always in motion. The continents drift by inches each year. Mountains rise and crumble. Oceans shift and whisper against their shores. And somewhere deep below, molten rock continues to flow, waiting for its time to speak again. Toba's voice may be quiet now, but the world still hums with its echo. The plants that grew back after the ash, the species that evolved in its aftermath, even the climate patterns that shaped our history, they all carry a trace of that one eruption. It's almost comforting in a way. The Earth has already endured so much and still it keeps going, finding new balance after every upheaval. Perhaps that's something we can learn from it, that survival isn't about control but adaptation, that even after darkness, light returns, and just as the last sparks of magma cooled in the crater of Toba, the first seeds of recovery began. Rain returned, the air cleared, slowly, quietly, life crept back. The forests spread again across Sumatra. The rivers carved new paths through fresh layers of ash. The planet healed itself the way it always does, given time. The night the Earth held its breath didn't end the story. It began a new one that would shape the climate, the continents, and the destiny of a species that learned to survive by watching the sky and listening to the ground. The same species that now looks back and tries to understand what it all meant. And as we drift deeper into that story, we'll move closer to the heart of the planet itself, to the slow pulse beneath our feet, and the hidden forces that remind us that Earth is not just our home, but a living, breathing world. It's strange to think that the solid ground we trust beneath us isn't really solid at all. It looks still. It feels firm. Yet if you could look deep beneath your feet, you'd find that the Earth is quietly alive, always shifting, always breathing. What we call land is just the surface of something in motion, a thin shell floating on a sea of molten rock. We don't hear it, not really. The sounds of the deep are too slow, too low for our ears. But every now and then, the planet clears its throat, and the result is something the surface never forgets. Volcanoes are one of the ways the Earth releases what's building inside it. Pressure, heat, gas, all of it gathering over millennia, searching for a way out. Most of the time, that pressure seeps out gradually, through quiet vents at the bottom of the ocean, or gentle plumes of steam curling into the sky. But sometimes, that slow, steady build-up turns into something else entirely. Beneath the crust, magma chambers form like hidden lakes of fire, pools of molten rock trapped between layers of stone. They expand, they contract, they pulse with energy. If you could stand deep inside the Earth's crust and look at one of these magma chambers, it would feel like standing beside a living heart. The walls tremble slightly. The molten rock glows in shades of orange and red. The gases swirl and rise like breath. It's not chaos, it's rhythm. Heat moving upward, minerals melting, crystals forming, gases dissolving and escaping. Every part of it follows the laws of physics, but the result feels almost alive. Most volcanoes are predictable in their own way. They erupt small and often, releasing just enough to stay balanced. But a few, like the one that once lay under Toba, don't follow that rule. They sleep for hundreds of thousands of years, quietly collecting energy until the weight of it becomes too much to hold. These are the sleeping giants of the planet, and when they wake, they change the world. Deep beneath Sumatra, long before there was a lake or a name for it, one of these giants began to stir. The island sits on a boundary where tectonic plates meet and grind past each other, part of the vast network of shifting crust that circles the Pacific Ocean like a scar. The Indo-Australian plate slides beneath the Eurasian plate there, sinking into the mantle and melting as it descends. Every inch it moves feeds the formation of magma, hot, buoyant, restless rock that slowly rises toward the surface. That process never stops. It's been happening since before there were trees, before there were oceans the way we know them. Over time, magma gathers in reservoirs, trapped by layers of cooler rock above. These layers act like a lid on a boiling pot. As long as they hold, the magma stays contained. But the longer they hold, the more pressure builds. The gases dissolved in the molten rock, mostly water vapour, carbon dioxide and sulfur dioxide, stay compressed until the balance tips. Then everything changes in a moment. In the case of Toba, that moment was unlike anything in human history. Imagine magma rising through cracks, feeding into a chamber the size of a small country. The pressure inside increases as more molten rock arrives from below. The chamber pushes upward, warping the ground above it. The surface bulges, invisible to anyone watching from a distance. Lakes tilt, rivers change course, the landscape subtly reshapes itself. For thousands of years, this happened silently. Nothing on the surface hinted at what was coming. The forest grew thick. The air was humid and alive with the sounds of insects and birds. Early humans walked those forests, unaware that the ground beneath them was slowly inflating, storing more energy than all the storms and earthquakes they had ever seen. Then, one day, the rock gave way. When the lid on a magma chamber fails, the result isn't just an eruption, it's a complete rearrangement of the crust. The pressure drops suddenly, gases expand violently, and the magma rushes upward at tremendous speed. Within seconds, the rock shatters. What follows is a chain reaction that feeds on itself. The more rock that explodes, the more pressure is released, the faster the eruption grows. In a regular volcano, magma flows out of a single vent. In a supervolcano like Toba, the eruption happens across a vast area, with multiple vents tearing open at once. The ground literally collapses as the chamber empties. What had been solid earth becomes a churning fountain of molten rock, gas and ash. The air ignites with heat. The blast wave travels faster than sound. Everything within hundreds of kilometers is incinerated in an instant. And then, as if the surface had taken a massive exhale, the land caves in. This collapse creates a caldera, a vast crater left behind when the chamber below empties out. In Toba's case, the caldera stretched more than 60 miles across. When it finally filled with water thousands of years later, it became the lake we know today. It's hard to imagine something so large that it can alter the planet's climate. But the evidence of these events isn't abstract. It's written in the rocks, in the minerals that formed as the magma cooled, and in the global patterns of ash distribution. Scientists have found Toba's ash layers not just in Sumatra, but in India, East Africa, and even the depths of the Indian Ocean. Those layers tell the same story, a single eruption so immense that it reached across continents. The scale of it can be hard to grasp, so it helps to compare. Mount Vesuvius buried Pompeii with about 4 cubic kilometres of ash. Mount St. Helens released around 1 cubic kilometre in 1980. Krakatoa, another Indonesian eruption in 1883, ejected roughly 20 cubic kilometres. Toba released over 2,000. Each number is staggering, but together they show just how different supervolcanoes are from anything we've known in recorded history. Scientists studying the remnants of these massive eruptions sometimes talk about magnitude, a measure that combines volume, height, and impact. Toba's eruption ranks at magnitude 8 on the Volcanic Explosivity Index, the highest possible category. It's not something that happens every few centuries or even every few millennia. We're talking about an event that may only occur once every 100,000 years or more. Yet, even knowing that, it's easy to forget what it means for the Earth itself. The planet doesn't view these eruptions as disasters. To Earth, they're part of its natural breathing cycle. Magma rises, crust cracks, heat escapes, new rock forms. It's all renewal, even if the process is violent by our standards. What we experience as chaos is just geology at work on a scale too large for comfort. The sleeping giant beneath Sumatra didn't intend to destroy. It simply followed the same rhythm that has shaped continents and oceans since the planet's beginning. Without that slow recycling of crust and magma, we wouldn't have mountains, islands, or even an atmosphere. The gases released by volcanoes over billions of years created the air we breathe today. Still, it's hard not to feel awe at the scale of what lies below. Imagine walking along the shores of Lake Toba today. The water is calm, framed by steep cliffs that rise like the rim of an ancient bowl. You might see villages built on its slopes, children playing near the edge, fishermen working from small boats. Everything looks peaceful, but beneath that tranquility is a reminder of immense power. The crust there is still thin. The magma chamber that caused the eruption has refilled, though not nearly to the same extent. The volcano is dormant, not extinct. That's the nature of sleeping giants. They rest, sometimes for longer than civilizations last. But their slumber is never permanent. Scientists monitor places like Toba constantly, using satellites and seismographs to track subtle changes in the ground. Tiny tremors, gas emissions, shifts in temperature, each one a whisper from below. Most of the time, those whispers mean nothing. The Earth moves all the time, but every so often something changes in the pattern and attention sharpens. When you look at the planet as a whole, you start to see how interconnected everything is. The crust, the mantle, the oceans, the atmosphere, they all exchange energy in endless cycles. Volcanoes play a role in maintaining that balance. They release carbon dioxide and other gases that help regulate the climate over geological time. They form new land and recycle old rock back into the deep earth. In a way, they're the planet's maintenance system, even if the process occasionally wipes the slate clean. The same cycle that destroyed vast regions around Toba also created new opportunities for life later. After the ash settled, the land became fertile again. Minerals from the eruption enriched the soil. Forests returned thicker than before. Lakes formed, supporting new ecosystems. It's one of the Earth's most reliable patterns, destruction followed by renewal. But from a human perspective, that renewal takes longer than we can easily imagine. For the people living in the shadow of the next potential eruption, it's hard to find comfort in geological time. We measure life in decades, not millennia. The Earth measures in millions of years. The two scales rarely agree. What's fascinating is how much we've learned from studying these sleeping giants. With modern technology, scientists can peer inside the Earth without digging, using seismic waves to map what lies below. These images reveal massive magma bodies, some partially molten, some mostly solid, stretching for miles. They're not empty caverns of liquid fire as once imagined, but complex systems of rock and melt, layered and evolving. Understanding these systems helps us predict how eruptions begin and how long they might take to build. In most cases, the process is slow, giving plenty of warning. Pressure builds, small earthquakes cluster, the ground swells. These are signs of movement, but they don't always lead to eruption. Many volcanoes show decades of restlessness before quieting down again. Still, the idea of something like Toba happening again captures our imagination, partly because it reminds us how small we are compared to the planet itself. It's not fear so much as humility. We've built cities, machines, and networks that circle the globe, but beneath it all, the same molten currents continue, unchanged by our existence. We depend on the thin surface layer that floats above them. Sometimes, when scientists talk about supervolcanoes, they use the phrase low probability, high impact. That's another way of saying unlikely but world-changing. It's a reminder that the Earth's calm is never absolute. Beneath every continent are systems capable of rewriting the story of life again. But they also remind us that these events, rare as they are, have shaped the world we know. Without them, the continents would be flatter, the climate less stable, the diversity of life smaller. It's easy to think of volcanoes as isolated features, mountains, vents, craters. But in truth, they're part of a continuous network that wraps around the planet. The Ring of Fire, stretching from the Andes to Japan, is one such region, responsible for most of Earth's volcanic activity. There, the same process that created Toba continues to this day, feeding eruptions both minor and massive. It's a constant reminder that the planet's surface is just the skin of something far more dynamic. When we talk about the sleeping giant beneath our feet, we're really talking about Earth itself, its restless nature, its cycles of pressure and release. The crust might seem permanent, but it's in constant conversation with what lies below. Every earthquake, every plume of steam, every small tremor is part of that dialogue. The planet moves, and life moves with it. And maybe that's part of why this story feels so strangely personal. Even though Toba erupted long before recorded history, its echoes are still with us. This soil that grew the first crops in Southeast Asia was rich because of volcanic minerals. The air we breathe contains carbon once trapped deep in the mantle. The continents we walk on are the cooled remnants of ancient lava flows. We live quite literally on the breath of volcanoes. The sleeping giant is not a monster. It's not malevolent. It's the Earth doing what it must to stay alive. The danger comes only when we forget the ground isn't fixed, that stillness is an illusion. And maybe remembering that, really feeling it, helps us find a kind of respect for the world that supports us. So, as we continue this journey into what happened after Toba awoke, keep in mind that what we call catastrophe is also part of creation. The same forces that nearly ended humanity also ensured its future by reshaping the planet we call home. The giant beneath our feet still sleeps, but its heartbeat is steady, its rhythm unchanged. And while we can't hear it in the quiet of the night, it's always there, far below, reminding us that the world has a pulse, a slow, patient pulse that will keep beating long after our small stories have faded. Before the eruption, before the sky darkened and the air turned to ash, the world was alive with sound. The Pleistocene landscape of what we now call Sumatra was a green and restless place. It was warm, wet, and heavy with life. The forests stretched endlessly, filled with ferns taller than a person and trees that rose like pillars. Rivers wound their way through the jungle, slow and brown with silt, feeding lakes that reflected clouds and canopy in equal measure. The air was thick with humidity and the calls of unseen creatures. If you had walked through it, you might have felt the ground soft beneath your feet, rich with decay and growth at once. Everything in that world was part of a cycle, where nothing ever truly ended, and nothing ever stayed the same for long. The Earth was in the grip of an ice age, though you wouldn't have known it standing there. The cold held the faraway poles, wrapping them in ice, but near the equator, warmth still reigned. Yet even here, the climate was not what it is now. The air carried more dust, the winds were stronger, and the seasons, while subtle, moved with a slow determination. Sumatra, surrounded by shifting seas and islands, was connected by land bridges to what we now call mainland Southeast Asia. Lower sea levels revealed paths between continents that would later vanish beneath the waves. Animals could travel farther, populations mingled, and the boundaries we draw on maps today did not exist. In this time, Earth's ecosystems were balanced on a knife's edge between ice and fire. great glaciers locked up enormous volumes of water, lowering the oceans by hundreds of feet. The planet's climate was dry in some regions and lush in others, shaped by global winds and shifting monsoon patterns. Grasslands spread across Africa and Asia, home to mammoths, rhinoceroses, and giant buffalo. Further north, tundra stretched across the continents, dotted with hardy plants and tough, cold-adapted animals. But here, in the tropics, life thrived. Dense forests covered Sumatra, Borneo, and the Malay Peninsula. Elephants moved through the trees, smaller than their Ice Age cousins but still powerful. Tigers hunted quietly in the shadows. Birds with bright plumage flashed between branches. The air carried the smell of wet earth and rotting leaves. Each day began with a chorus of insects and ended in a thick dusk that arrived quickly, as if the sun had simply slipped beneath the horizon without warning. Humans lived here too, though they were not many. The ancestors of modern humans had already spread across Africa and into parts of Asia. Small groups roamed the forests and open plains, living from what the land offered. They gathered fruits, hunted with sharpened tools, and built shelters from branches and animal hides. They had no written language, no wheels, no cities, but they had memory and fire and the quiet determination that has always defined our species. Their world was smaller than ours, but also more immediate. Every sound in the forest mattered. Every change in the wind carried meaning. The smell of smoke could mean danger or safety. The sound of thunder might mean a storm that would refill streams or flatten shelters. Life was a constant negotiation with nature, a balance between risk and survival. In places near the great volcanic regions, the people would have seen signs of the deep earth's restlessness without understanding what they meant. Steam rising from the ground, warm springs that never cooled, stones that trembled when the earth shifted far below. These things were not unusual in their eyes. The planet had always moved, always spoken through small tremors and cracks. To them, it was simply the way the world behaved. There were no words for volcanoes, not as we have now, no recorded myths of fire mountains or sky-darkening eruptions. But there must have been stories told around their fires, small attempts to make sense of the world's unpredictable moods. When lightning struck trees and set the forest ablaze, they saw the earth's power. When the ground shook, they felt its anger. They didn't know that beneath their feet a chamber of molten rock was slowly gathering the energy that would one day change the course of history. Toba itself was just part of the landscape then, a region of forests and rivers, dotted with hills and low mountains. The volcano's earlier eruptions had shaped the terrain, creating fertile soils where plants grew thickly. Streams flowed from its slopes, carrying minerals that fed the lowlands. Life, as it always does, took advantage of this richness. The land was abundant, the water plentiful, and the climate stable enough for countless species to thrive. The world at that time was connected in ways that are easy to overlook now. Winds carried pollen, dust, and even microorganisms between continents. Ocean currents linked distant coasts. Animal migration spanned thousands of miles. The entire planet was a single interwoven system, just as it is today, though few creatures alive then would have known how fragile that balance truly was. What scientists later learned about that world comes from the most patient kind of detective work. Fossilized pollen trapped in layers of sediment shows what plants once grew there. Tiny fragments of charcoal reveal when fires burned. The remains of animal bones tell which species roamed the forests and which disappeared. Even the isotopes in the shells of ancient plankton can tell us how warm or cold the oceans were, giving us a record of global conditions before everything changed. From those clues, a picture forms of a world both familiar and alien. Familiar because life thrived, and the rhythm of day and night was the same as it is now. Alien because the scale of time was different, and the balance of the planet hung on processes far larger than anything we could control. Volcanoes, ice sheets, ocean currents, and orbital shifts governed the climate. The people who lived through it simply adapted as best they could. Their tools were simple but clever. Flint, bone and wood shaped into points and edges. Their shelters were temporary, built to be moved when food ran out or weather changed. Their fire was everything. Warmth, protection, light, and a way to cook food that would otherwise be impossible to eat. Around that fire they might have sat together, listening to the forest sounds fade into the night, unaware that somewhere beyond the trees the earth itself was gathering fire on a scale their minds could never have imagined. In those ancient communities every member mattered. A child's laughter, an elder's story, a hunter's success. Each one kept the group alive. Their understanding of the world was shaped by what they could see and touch, yet they were closer to the earth's rhythms than we are now. They noticed the way the air smelled before rain, the subtle trembling of the ground before a quake, the change in bird calls that signalled shifts in weather. Knowledge passed by observation, not by books or instruments, but by memory and repetition. The forests around them were more than resources. They were their world. The tall trees filtered light into a constant twilight, their roots winding through the dark soil like veins. Ferns grew thick along the ground, and orchids clung to trunks high above. The forest floor was alive with insects, reptiles, and small mammals. Large animals moved carefully through the undergrowth, following trails known only to them. The nights were darker than ours. No cities, no artificial glow, only the moon and stars. And when the sky was clear, the stars must have been overwhelming, uncountable, stretching across the black in patterns that perhaps no one named, but everyone noticed. The animals that lived in this time were part of an older lineage. Many were species that would later vanish, replaced by smaller, more adaptable forms. Giant deer with antlers spanning more than a man's height grazed the open spaces. Elephants with longer hair and straighter tusks wandered through the forests. Predators watched from shadows, silent and calculating. The balance of predator and prey, growth and decay, was exact and delicate. This was the world as it stood on the eve of Toba's awakening. Vibrant, interconnected, unprepared. The planet's climate systems were stable but sensitive. A shift in temperature of just a few degrees could change rainfall patterns, freeze or thaw vast regions, and alter the course of rivers. The eruption that was coming would do all of that at once. Before that moment, though, everything looked ordinary. The magma beneath Toba had been slowly accumulating for tens of thousands of years. The chamber expanded quietly, compressing gases, building pressure. The crust above it bent upward by small amounts, maybe inches per century, too slow for any creature to notice. There would have been no sign of danger from the forest floor, no warning from the rivers, no hint in the air. The volcano's power was hidden deep below, patient and absolute. The day before the eruption, if such a day could be imagined, might have looked like any other. The sky bright with tropical clouds, the air still heavy with the promise of rain. Perhaps a storm passed in the afternoon, soaking the ground and filling the streams. The forest would have smelled rich and alive. The calls of cicadas filled the air. Somewhere, a small group of humans prepared their food and watched the fading light through the trees. The ground beneath them trembled slightly, but it had done that before, nothing unusual. The sleeping giant gave no clear signal. Even in the final moments, the signs would have been subtle. Animals might have moved restlessly. Birds might have flown away. The air could have tasted faintly metallic. But there was no sky darkening yet, no roar from below, no column of smoke to signal what was about to happen. Then, within hours, perhaps minutes, everything changed. When the eruption began, the first sound would have been a deep rolling vibration, not a sharp explosion, but a low growl that grew louder and louder until it became the only sound. The ground would have lifted, cracked, and then broken apart. The air would have turned hot enough to ignite the trees. Rivers would have boiled away in seconds. The forest, the animals, the people. all of it swallowed in a single moment of Earth's exhale. But before that instant, before the first fracture opened in the ground, the planet had known peace. For thousands of years it had been a world of steady patterns. The sun rose and set, the rain fell, the forests grew and decayed and grew again. Life adapted, unaware that all of it was balanced atop a reservoir of molten rock the size of a mountain range. When we look back on that time now, we can't help but wonder what it would have felt like to live in a world so raw and direct. Every need was met by the land. Every danger came from nature itself. The people then were not separate from the world. They were part of it in a way we can barely imagine. And perhaps that connection gave them a resilience that helped their descendants survive what was to come. The quiet before Toba's eruption was not an ending, but a pause in the planet's ongoing movement. Every leaf that turned toward the sun, every ripple in the rivers, every heartbeat in the forest was part of that calm. Then the calm broke. The energy that had been building for millennia finally escaped. The surface collapsed. The air filled with ash, and the world began its long descent into shadow. And yet, even as we trace that catastrophe through time, we can still picture what came before. The forests dense and breathing, the rivers wide, the sky blue and open. The memory of that world survives in sediments and fossils, but also in our imagination, in the quiet understanding that life always begins again after the fire. There comes a moment in every volcanic eruption when the Earth stops holding back. The pressure that has built quietly for centuries suddenly finds release, and in that instant, the calm world above changes forever. When Toba awoke, there was no warning that any living creature could have understood. It began deep underground, in silence, in heat. Magma surged upward through cracks, pushing its way toward the surface. The rock above, which had held firm for thousands of years, began to tremble and crack. At first, those tremors might have been mistaken for ordinary quakes, the kind that came and went like a sigh from the earth. But this time, the shaking didn't stop. When the final layer of rock gave way, the eruption began with an explosion so massive it tore the island apart. A column of incandescent gas, ash and pulverized rock burst into the sky at speeds no eye could follow. It was the kind of violence that defied scale, where numbers failed to mean anything. The eruption's column climbed tens of miles into the atmosphere, piercing through clouds and reaching the stratosphere. If someone had been watching from space, they would have seen a vast plume rising, spreading outward, forming a blanket that began to wrap the planet. At ground level, there was no time to comprehend what was happening. The forests that had stood for centuries were gone in moments. Shockwaves radiated outward faster than sound, flattening everything within hundreds of miles. The air became fire. Pyroclastic flows, massive currents of hot gas, ash and rock fragments, cascaded down the slopes at hundreds of miles per hour, hotter than 1,000 degrees. Nothing living could survive their touch. Entire valleys filled with them, rivers vanished beneath them, and the ground itself seemed to move. The sky darkened almost immediately. Ash particles began to fall, not as a gentle drift, but as a storm that blotted out the sun. The light dimmed to grey, then black. Day turned to night, and the night stayed. The roar of the eruption drowned out everything else, a sound so enormous it didn't just fill the air but the body, vibrating through bone and muscle. Even far from the epicenter, the noise must have been terrifying, a constant low thunder that rolled across the horizon for hours. The column of ash that rose above Sumatra was one of the largest ever produced by any volcano. Scientists estimate it reached more than 40 kilometers high. As it expanded, it carried with it a mixture of fine particles and gases, sulfur dioxide, carbon dioxide, water vapor, all of which spread rapidly into the atmosphere. The gases reacted with sunlight, creating aerosols that reflected heat away from the Earth. The cooling began almost immediately. For days, the eruption continued, cycling through phases of collapse and renewal. Each time the column grew too heavy with ash, it fell back toward the earth in a cascade of glowing clouds. Then pressure built again, and another surge followed. The process repeated again and again, reshaping the landscape in ways that are still visible today. The island of Sumatra, once marked by hills and forests, became a vast crater. If we could somehow watch it unfold in slow motion, we would see the earth lifting and collapsing at the same time. The centre of the island dropped as the magma chamber emptied. Massive blocks of crust sank into the void below, while around the edges, fractures widened and deepened. The shape of the caldera formed gradually, a scar growing outward as each new explosion tore away more of the surface. Far from the eruption, the world was still. But that stillness was deceptive. Fine ash began to drift across the Indian Ocean, carried by upper-level winds. Within days it was falling over India, East Africa, and the Arabian Peninsula. Within weeks, it circled the globe. Tiny grains of volcanic glass settled into the soil, into lakes, into the open sea. Some of those grains still exist today, buried in sediments that scientists can trace back to this one event. Each fragment is a record of that darkened sky. In the air, sulfur dioxide turned to sulfuric acid droplets, scattering sunlight and painting the atmosphere with strange colours. The sunsets during those first days after the eruption must have been eerie, blood red, then fading to dull grey. The temperature dropped by degrees that no living creature could measure in the moment, but the effects began to spread. The planet, for all its vastness, reacts quickly to the loss of sunlight. For humans, the eruption itself would have been incomprehensible. If anyone was close enough to see it and somehow survived the first hours, they would have seen the horizon itself dissolve. Ash clouds moving like oceans, lightning flickering inside them as static built and discharged in blinding flashes. The rain would have turned to mud, thick with dust. Breathing would have been almost impossible. The sound never stopped. A continuous roaring, hissing, crackling, like the planet exhaling for the first time in ages. In the modern world, we measure eruptions by their explosivity, by the amount of material ejected, by their chemical signatures. But those are scientific conveniences. In that moment, there were no measurements. There was only survival, or the end of it. The eruption lasted perhaps 2 weeks in total, though the main event, the one that changed the sky, may have taken only a few days. By the time it was over, the island had changed shape entirely. Where once there had been mountains, now there was a vast hollow. That hollow filled over time with water from rain and rivers, forming Lake Toba, the world's largest volcanic lake. The ashfall from Toba was so widespread that it covered much of South Asia in a layer several inches thick. In some places near the eruption it was tens of feet deep. Forests collapsed under its weight. Rivers were dammed, changing their courses. The ecosystems that had thrived before were gone, replaced by a grey desert that would take centuries to heal. The air remained hazy for months. The cooling that began with the eruption didn't stop when the ash fell. Scientists studying ice cores from Greenland and Antarctica have found traces of Toba's eruption, microscopic layers of ash, and chemical signatures of the gases released. These show a sudden drop in global temperatures that may have lasted several years. The sunlight reaching the surface of the planet was reduced, photosynthesis slowed, and the web of life began to strain. But at the scale of the eruption itself, none of that mattered. The Earth wasn't concerned with climate or consequences. It was simply equalizing pressure. The magma that had been trapped for so long was finally free. When the gases expanded, when the molten rock met the air, it created something that looked like chaos, but was, in a strange way, order restored. The Earth had released what it needed to release. For scientists trying to reconstruct the event today, the challenge is not understanding how it happened, but grasping its sheer magnitude. The energy released was equivalent to several thousand times all the nuclear weapons ever detonated. The ash cloud was so vast that it altered the global climate. The fallout may have persisted for a decade or more, with effects that reached every corner of the planet. And yet, standing at the site today, none of that power is visible. The lake is calm, villages line its shores, the air smells of rain and vegetation. It's difficult to connect the serenity of the present with the violence of the past. But that's the nature of Earth's memory. It doesn't forget, but it covers its scars with new life. When we talk about the sky turning to stone, we're describing something that really happened. The ash, fine as powder, filled the air so completely that sunlight could barely penetrate. To anyone living beneath it, the world would have seemed to end. The brightness of the sun replaced by a dim, shifting glow. The horizon lost, the stars gone. Day and night merging into a single, long twilight. The air cold, heavy, unbreathable. Over time the ash settled, layering the ground with grey dust that hardened into rock. These tough layers, as geologists call them, can still be found across Asia, a geological fingerprint of that one eruption. In some places the layers are meters thick, in others just a thin trace. But they all carry the same composition, the same microscopic shards of glass that once floated through the upper atmosphere. That ash is more than debris, it's information. By studying it, scientists can learn the chemical makeup of the magma, the temperature of the eruption, and even the speed at which it cooled. It tells a story of pressure and release, of gases expanding, of rock transforming into something else. Each fragment is a frozen moment from that day when the Earth let go. The eruption didn't just affect the immediate region, it reshaped ocean currents and atmospheric circulation. As the aerosols spread, they cooled the planet unevenly, creating temperature contrasts that changed wind patterns. Rainfall shifted, monsoons weakened, drought spread in some regions while floods appeared in others. The balance of the global climate tipped, and it took thousands of years to stabilize again. For humans, those years were a trial of endurance. The groups that survived had to adapt to scarcity. The plants they relied on grew less reliably. The animals they hunted migrated or died off. The landscape changed around them, and they followed the changes as best they could. Their descendants would carry traces of that struggle in their DNA, signs of a population bottleneck that reduced humanity to a few thousand individuals. When scientists discuss Toba today, they often use words like catastrophic, apocalyptic, or extinction level. But those words, while accurate in scale, don't quite capture the slow, persistent way the effects unfolded. The eruption was instantaneous, but the aftermath stretched for decades. The ash didn't vanish when the sky cleared. It lingered, covering rivers, altering soil chemistry, reshaping ecosystems. Even so, the planet did what it always does. It adapted. Plants began to grow again in the nutrient-rich ash. Water carved new channels through the hardened deposits. Over time, forest returned. New species filled the empty niches left by those that didn't survive. The Earth moved on, reshaping itself into something new. It's remarkable to consider that this eruption, which nearly ended humanity, also played a role in the evolution of the species that would one day study it. By forcing migration and adaptation, it may have accelerated changes in human populations, shaping who we became. The darkness that followed was not just a period of survival, but of transformation. In geological time, even the greatest catastrophes are fleeting. The eruption that darkened the sky for years was just a moment in the planet's long rhythm. The magma cooled, the caldera filled with water, and life returned. But traces of that moment remain everywhere, in the rocks, in the climate, in us. It's hard not to imagine what it must have felt like for the last sparks of the eruption to fade. The air filled with drifting ash, the heat giving way to cold, the silence returning slowly after weeks of sound. Perhaps there were survivors near the edges of the devastation who saw the sun again after a long grey twilight. The first clear day must have seemed miraculous. The light weak but visible. The world altered but still there. For those who endured, the landscape around them was unrecognisable. Forests gone, rivers rerouted, animals vanished. The ground covered in thick layers of ash that made travel almost impossible. Every breath filled the lungs with dust. Yet, as the weeks passed, small signs of life reappeared. Green shoots pushing through the ash, insects returning, birds finding places to land again. The planet began to heal. When scientists today drill into the sediments of lakes and oceans, they find Toba's fingerprint layered between older and younger deposits. Each layer tells of a world that changed and then continued. That continuity is the quiet truth of the Earth. It endures its own violence, it recovers, it reshapes, and it continues. The day the sky turned to stone was not the end of life, but a reminder of its fragility. The Earth, for all its age and power, can change in an instant. And we, small as we are, exist because some of those who came before found a way to survive what must have felt like the end of everything. And in the cooling silence that followed the fire, when the ash began to settle and the air grew still, the long winter that would reshape the planet had already begun. After the fire and the noise, after the roar that carried across the seas, there was only silence. The sky was still thick with ash, but the eruption's voice had faded. What remained was the slow fall of dust, a constant, unending drift of fine grey particles that turned day into something between morning and night. It was the kind of silence that feels heavy, not peaceful, where even the smallest movement stirs the air like smoke. Ash began to fall before the last explosions had stopped. It started as a faint haze, then thickened into a storm. Each grain was a fragment of the earth itself, shattered and carried upward before returning to rest. The pieces were so small that they could float for hours before touching the ground, and there were so many of them that they filled the air across continents. The light that filtered through the ash turned strange, diffuse, pale, without warmth. The sun looked like a ghost behind a veil. On the island that had once held Toba's forests, the ash fell thickest. In some places it covered the ground in layers deep enough to bury trees entirely. The weight of it pressed down on everything. The few surviving plants bent and broke beneath it. Rivers choked with sediment until they stopped flowing altogether. Lakes filled with ash that sank in soft layers, one on top of another, compressing into a grey sediment that would one day become stone. Even far from the eruption, the sky carried the memory of what had happened. Winds lifted the ash high into the stratosphere, where it spread in wide bands that encircled the globe. Within weeks it began to settle in places that had never seen a volcano. The grains were light enough to travel thousands of miles, but heavy enough to fall eventually, blanketing everything in a thin layer of dust. In what is now India, layers of Toba ash still rest beneath the soil. They stretch across rivers and plains, a pale band in the earth that geologists can read like a page. The same band appears in East Africa, thousands of miles away, where it marks the same moment in time, a global layer, a shared horizon of memory. Each location tells the same story, a brief moment when the sky emptied itself of earth. The ash that fell contained the chemical fingerprints of its origin, traces of silica, iron, magnesium and sulfur. Each element tells part of the story. Silica made the ash light and sharp, easily carried by wind. Sulfur combined with water vapour to form droplets that spread sunlight, cooling the surface. Iron and other minerals enriched the soil where it eventually settled, though that enrichment would take centuries to matter. At first, it was only destruction. For the people and animals that survived, the ash was more than a nuisance. It was a barrier between them and the world they had known. Breathing it burned the lungs. Drinking water tainted with it caused sickness. The air, thick with suspended particles, made vision short and unclear. Sound was muffled. Even the wind seemed to move slower. Every step raised small clouds that hung in the air before settling again. The ash changed how the world smelled, tasted, and felt. The rain that fell through it turned to mud as it reached the ground, coating everything in a fine layer of grey paste. Plants that managed to survive the heat were smothered by it. The forest floor disappeared under a uniform carpet that hid paths, streams and landmarks. For months, maybe years, the landscape remained unrecognisable. Yet even in that devastation, something began to happen. As the ash settled, it created layers that would preserve everything beneath them. The remains of trees, leaves and bones became trapped, sealed from decay by the fine grains. Over thousands of years, those layers turned to rock, preserving a record of the moment when Earth covered itself. When scientists dig through these deposits today, they find the details of that lost world, the pollen from plants that no longer exist, the impressions of leaves pressed flat against the ash, the shapes of animals caught in the fall. Each discovery is a reminder that the ash didn't just destroy, it also recorded. It froze time in place. It's because of that we know so much about what came before and after. The ash acted as both eraser and archivist, wiping away the surface but keeping its memory beneath. As it spread through the atmosphere, the ash began to influence the entire planet's systems. The particles that stayed suspended reflected sunlight, reducing the amount of heat that reached the surface. Temperatures dropped by degrees that changed the course of seasons. Crops did not yet exist, but the wild plants and trees that sustained early humans struggled to grow. Some regions dried, others flooded as weather patterns shifted. The oceans absorbed much of the fallout. Ash settled into the waves, sinking slowly until it reached the seabed, forming layers that still lie undisturbed. The iron and other nutrients within it fed plankton blooms, temporarily increasing ocean productivity. But the cooling air and reduced sunlight offset that benefit. Ice expanded near the poles. Rainfall patterns changed. The balance that had held steady for millennia began to slip. Scientists who study these effects use computer models to understand how such a massive eruption could alter the global climate. They estimate that temperatures may have dropped by as much as 5 degrees Celsius on average, with more severe cooling in certain regions. It might not sound like much, but such a change can transform the entire planet's weather. The difference between ice and warmth, between abundance and scarcity, can rest on just a few degrees. What makes Toba remarkable is not only the size of the eruption, but the way its influence reached everywhere. The ash that fell like snow across Asia and Africa became part of the ground future generations would walk on. Each grain was a relic of the fire that had burned halfway around the world. The earth had made itself known, and the mark it left was impossible to ignore. In some regions, the ash created strange effects. Lakes turned opaque, their surfaces coated with floating dust. Rivers that once ran clear became thick and sluggish. The reflection of the dim sun through the haze gave everything a muted glow, like perpetual twilight. Plants adapted slowly, but many could not. Forests that once thrived turned to barren plains. The animals that survived had to move or starve. The rhythm of migration shifted. Entire ecosystems changed direction. For humans, survival became a daily challenge. Small groups that had once relied on predictable patterns of fruiting trees or migrating herds found those patterns broken. The air was colder, the nights longer, and the food scarcer. They followed the remnants of rivers, searching for places where life still clung on. Fires became harder to keep lit in the damp, as ash-filled rain smothered the flames, but they persisted. Humanity has always persisted. Modern scientists have found evidence of this persistence in the form of tools and artifacts buried within Toba ash layers. In parts of India, stone tools appear both below and above the ash deposit, suggesting that humans lived through the eruption and its aftermath. These discoveries hint that while the eruption brought unimaginable hardship, it did not wipe humanity out entirely. Small groups endured, adapting to the altered world. What's extraordinary about the ash is how far it carried the story. Every handful of soil that contains even a trace of Toba's dust connects back to that single eruption. It's a geological timestamp, a shared moment written into the planet's crust. When researchers find that layer in a sediment core or an archaeological dig, they know exactly when they are, 74,000 years ago, when the Earth nearly died and began again. If you could touch one of those ancient layers, you'd be holding the dust of that day, the same ash that once floated above the forests, the same particles that turned sunlight cold. Each grain, smaller than a grain of sand, carries within it the record of heat and pressure so immense that it changed rock to glass. Even after all this time, those grains still reflect light under a microscope, tiny fragments of a long-forgotten sky. The phrase scientists often use to describe the Toba ash layer is isotopic marker. It's a point in time so distinct, so globally distributed, that it serves as a reference for everything around it. Above it, life that recovered. Below it, life that never saw the light again. It's a dividing line, and yet it's also a bridge, connecting the past to the present through the quiet persistence of minerals and memory. As the years passed, the ash slowly became part of the soil. Wind and water broke it down, mixed it with organic matter and spread it thin. Plants began to grow again, roots piercing through the hardened layers, drawing nutrients from what was once destruction. The same minerals that had killed forests in the beginning later fed their regrowth. The cycle continued, as it always does. The earth gives and takes in turns, and from every fall something new rises. For all the scale of the Toba eruption, for all the destruction it caused, the ash it left behind would eventually give life back. Volcanic ash contains minerals that enrich the ground once it weathers: silicon, iron, calcium and magnesium, all of them essential to plant growth. Over centuries, rain broke the ash into smaller particles, unlocking those nutrients. Forests returned, not the same as before, but new, adapted to the altered climate. The same process that turned skies dark ended up feeding the roots of the next generation of life. That's one of the Earth's most enduring traits, its ability to turn devastation into renewal. To the people who survived, that change must have been invisible. Their days were filled with cold, hunger and uncertainty. But in the slow language of geology, the recovery had already begun. When modern scientists drill into the sediments of lakes or oceans to find the Toba ash layer, they aren't just studying a volcanic event, they're studying the moment when life paused and began again. The layer serves as both a scar and a foundation. It separates one world from another, yet both worlds belong to the same planet. Even the ice of Greenland carries a trace of it, tiny specks of ash trapped in bubbles of ancient air. Those specks link the frozen north to the tropical south, connecting two extremes of the planet through a single event. That global reach is what makes Toba unique. It wasn't just a local catastrophe, it was a planetary moment when the Earth reminded everything living upon it that nothing is permanent. When you think about the ash now, it's easy to imagine it as something lifeless: dust, stone, residue. But that ash was alive in its own way. It carried within it the chemistry of the planet's interior, the breath of its molten heart. When it fell, it became part of the cycle of erosion, sedimentation, and renewal. The same particles that once darkened the sky are now part of the soil beneath forests and fields. Some may even be under your feet, mixed invisibly into the ground you walk on. Every handful of earth carries stories like that. Layers of past eruptions, floods and extinctions, each one part of the same ongoing rhythm. The ash that fell from Toba didn't just mark a moment in time, it became time itself, settling slowly, grain by grain, across a world that was already changing. The calm that followed its fall wasn't peace, it was the deep quiet that comes after something immense has passed. The air cooled, the wind stilled, and the world seemed to wait. The people who lived through it would have seen the haze linger for months, perhaps years, before the sky finally began to clear. When sunlight returned, it was weaker, colder. The world had entered a new phase, a long winter that would test everything alive, and beneath that grey sky the ash remained, a thin, persistent memory of the day the Earth exhaled. When the last clouds of ash drifted away from the eruption site, the damage had already spread far beyond the horizon. The sunlight that reached the surface of the Earth no longer carried the same warmth. Days grew shorter, not because the planet had tilted or changed its orbit, but because the air itself had become a mirror. Tiny droplets of sulphur and ash still floating high in the atmosphere reflected sunlight back into space. The result was a dim, cold light that touched everything equally and warmed nothing. It happened slowly enough that no one could name the moment it began, yet quickly enough that life felt its grip within a generation. The first signs were subtle, frost appearing where it had never been before, rain turning to sleet, winds carrying a chill even near the equator. Plants that once grew easily began to fail. Seeds sprouted later and fewer of them survived. The rhythm of the seasons, which life had relied on for thousands of years, faltered. The temperature dropped across the globe by several degrees. In the polar regions, ice expanded rapidly, reflecting even more sunlight and deepening the cooling effect. Snow fell farther south than it had in centuries. The monsoon rains weakened, turning fertile lands into dry plains. Forests withered, rivers shrank. The interconnected systems that sustained life began to fracture. For humans, the change would have been devastating. The small groups scattered across Africa and Asia lived close to the edge of survival, even in the best of times. They depended on the abundance of plants and animals that followed predictable patterns of growth and migration. When those patterns broke, so did the delicate balance that kept them alive. Imagine living in a world where every day feels like the beginning of winter. The mornings are grey, the air heavy and cold. The sky holds no colour, only a faint silver light that never becomes bright. The nights stretch endlessly, and the stars are dim behind the haze. The fires that once brought warmth and comfort burn weakly, the damp air smothering their strength. The world that had once been vibrant now feels distant and muted. The volcanic winter that followed Toba's eruption is believed to have lasted at least 6 years, possibly longer. During that time, the average global temperature may have dropped by as much as 5 degrees Celsius. That might not sound dramatic compared to the differences between day and night, but on a planetary scale, it was enough to transform entire ecosystems. The Earth entered a state of deep, prolonged imbalance. Ash and dust still fell from the sky, though less heavily than before. Each new rain brought more of it down, coating the ground in thin layers. The air smelled faintly of sulphur and earth. The sunlight that did reach the surface was filtered through a haze so thick that shadows seemed to vanish. Plants struggled to photosynthesize in the dim light. Trees shed leaves and didn't regrow them. Grasses turned brittle and died. The animals that fed on them starved, and the predators that hunted those animals soon followed. The food chains collapsed in slow motion. First the small herbivores, then the larger ones, and finally the scavengers. In regions far from the eruption, life continued, but differently. The temperature drop shifted rainfall patterns, causing droughts in some areas and floods in others. In Africa, lakes shrank or disappeared entirely. In Asia, monsoon cycles failed. Crops didn't yet exist, but the wild plants that had sustained early humans became scarce. The people who lived through that time didn't understand climate or atmospheric chemistry, but they understood change. They would have seen the skies grow dimmer, the air colder, and the land less generous. They would have learned quickly that the world they had known was gone. Survival meant moving, following what remained of the warmth, finding new sources of food, learning to adapt to a colder, harsher Earth. For some, that meant travelling long distances, across regions they had never seen before. Rivers that once guided them turned into barren beds. Forests gave way to open plains. They followed the migrations of the animals that still lived, moving with the herds, always searching for the next place to find sustenance. fire became even more essential, not just for cooking, but for endurance. It was the only defense against the cold that never seemed to end. The population of humans alive at that time may have been reduced to a fraction of what it once was. Genetic studies suggest that all modern humans descend from a small number of survivors, perhaps a few thousand individuals. This bottleneck left a lasting mark in our DNA, a sign of how close our species came to extinction. The long winter after Toba didn't just test life, it almost erased it. In regions far from the eruption, like Africa, where some of these survivors lived, the effects were still severe. Drought gripped the land for years. Vegetation declined. Lakes that had once been full became dry basins. Those who lived near the coast may have fared better, relying on shellfish and marine life when inland resources vanished. The adaptability of humans, their ability to eat a wide variety of foods and to work together, may have been the only reason they endured. The volcanic aerosols that caused the cooling eventually settled out of the atmosphere, but their effects lingered. The ice sheets grew larger, the feedback loops of cooling continuing for decades. The planet didn't simply return to normal when the sky cleared, it had shifted into a new balance. The ecosystems that emerged after the eruption were not the same as those that had existed before. In some ways, the Toba eruption accelerated changes that were already underway. The Earth was in the midst of an ice age cycle, and the eruption deepened it. The glacial advance that followed covered more of the northern hemisphere, locking up even more water as ice and lowering sea levels further. The world became more fragmented, with isolated populations separated by vast uninhabitable regions. For the survivors, this fragmentation may have been both challenge and opportunity. Smaller groups adapted to their specific environments, leading to the diversity that would later define humanity. Each region became a unique experiment in survival, some near coasts, others in valleys, others on high plateaus. Over thousands of years, those differences accumulated, shaping cultures, technologies, and even appearances. But all of that began in the shadow of that winter. The psychological weight of such time is difficult to imagine. Every morning began with the same dim light, the same cold wind. Every night, the same uncertainty. The forest sounds that had once been familiar, the calls of birds, the chatter of insects, were gone or faint. The silence of the world must have been immense. It's likely that many animals sought shelter during those years, retreating to pockets of warmth near geothermal springs or low valleys where cold air didn't settle as deeply. Humans may have done the same, gathering around heat sources wherever they could find them. The memory of that need for warmth, for fire as survival, would stay with us as a species forever. Fire wasn't just a tool anymore. It was life itself. The evidence of this cold period is preserved in ice cores and sediments all over the world. Thin layers of sulfate deposits mark the fallout of volcanic gases, and temperature proxies from oxygen isotopes show a sharp decline around the same time. In some cores, there's a gap in biological activity, a pause in growth that matches the years after the eruption. The Earth itself carries the record of that long winter in every layer of its frozen memory. And yet, even during the worst of it, life persisted. Certain plants adapted to lower light levels. Mosses, lichens, and hardy grasses began to colonize the ash-covered lands. These early pioneers stabilized the soil, preventing erosion and allowing more complex species to follow. Insects returned, feeding on the new vegetation, and the web of life began to rebuild. The recovery was uneven. Some regions rebounded faster than others. Areas near the equator, where sunlight remained strongest even through the haze, recovered first. Those closer to the poles remained locked in ice, but the overall direction was the same: slow, steady renewal. The volcanic winter had broken the old order, but from that break new possibilities emerged. It's worth considering what this meant for early humans in more detail. In the face of scarcity, cooperation became essential. Groups that shared food, knowledge and shelter had a better chance of surviving than those that didn't. The social instincts that define humanity today, empathy, communication, the sense of belonging, may have deepened during this time. It's possible that the bonds forged in that shared struggle became the foundation for the social complexity that would later allow civilizations to form. Even the idea of migration, of leaving one's home in search of something better, might trace its roots to this era. The long winter forced movement. The paths carved by those journeys eventually connected the continents, spreading humans across the globe. The cold that almost ended us may have been what pushed us to explore, to adapt, to spread, to endure. For years, perhaps decades, the planet remained dim. The sky never fully cleared. The ash that had once fallen now sat locked in ice, pressed into soil or carried away by the wind. The earth looked different, pale, quiet, subdued. The forests that returned were not the same as before. New species of plants filled the voids left by those that couldn't survive the cold. Animals migrated into new territories, changing the balance of ecosystems everywhere. Eventually warmth returned, not suddenly, but in small increments. The haze thinned, the sunlight strengthened, snow melted from the hillsides. Rivers began to flow again. The first plants to bloom must have seemed like miracles. Fragile green life pushing through the grey ash. The animals followed, cautious but hungry. The people who had survived the long cold would have seen those signs and known that the earth was shifting again, slowly, back towards something they recognised. In geological terms, the recovery was fast. In human terms, it was slow enough to be a lifetime. Entire generations may have lived and died under the dim sky before the light fully returned. Those who survived passed down stories, not written, but spoken, carried through memory. Perhaps they spoke of the dark years, of the fire that came from the ground, of the endless cold. Maybe those stories became the seeds of myths that would one day describe floods, storms, or battles between sky and earth. Every layer of rock and ice that records this period carries the same message. The earth was pushed to its limit and found balance again. The long winter that followed the eruption was not a punishment or a warning. It was simply part of the planet's rhythm, one phase in an endless sequence of creation, destruction, and renewal. Even now, the legacy of that winter lingers. The genetic traces of the survivors, the distribution of plant species, the composition of the soil, all of it shaped by those years of darkness. When we look at the diversity of life today, we're seeing the outcome of that struggle. The Earth nearly ended, but it didn't. It simply changed, and everything alive had to change with it. As the cold began to ease and the light grew stronger, the ash that had once been the sky's burden became part of the soil beneath new forests. What had fallen as death became the ground of renewal. The long winter faded, not with a sudden thaw, but with the slow return of colour and sound. The world was still fragile, still cautious, but alive once more. And beneath the calm of that returning warmth, the earth continued its quiet work. The magma chambers deep below cooled, the crust settled, and the winds began to move differently. The planet, as always, carried on, indifferent and magnificent, ready for whatever would come next. When the worst of the cold began to lift, the world that emerged was smaller. Not smaller in size, but in life. The forests were thinner, the herds fewer, and the voices of the earth quieter. What had once been a crowded, thriving planet now seemed subdued, a place of scattered survivors clinging to warmth wherever it could be found. The long winter had left scars on everything it touched, and among the deepest of them was the one it left in humanity itself. Before the eruption, humans were already few in number. The species had only recently spread beyond Africa, moving into Asia and beyond, following rivers, coastlines and herds. They lived in small groups, connected by kinship and habit rather than borders or nations. Their tools were simple, their shelters temporary. They moved with the seasons, living lightly on the land. But after the eruption, that quiet network of wanderers thinned. The volcanic winter cut through populations like an invisible tide, leaving only isolated pockets of people scattered across the continents. Genetic studies today show the evidence of that reduction, a bottleneck so severe that it nearly erased our species. Before Toba, there may have been tens of thousands of humans living across Africa and Asia. Afterward, there might have been only a few thousand left, perhaps fewer. Some estimates suggest as few as 2,000 individuals carried forward the lineage that would become all of us. Every living human today, no matter where we are, carries the genetic traces of that narrow escape. To imagine such a time is to imagine a world of silence and endurance. Picture small bands of people moving through landscapes emptied of sound. The animals they once hunted gone, the plants they once gathered frozen or dead, the air cold enough to sting the lungs, nights so dark that even the stars look distant through the haze, food scarce enough that every discovery, every edible root or surviving animal became a cause for celebration. Survival in that world wasn't about strength, but adaptation. It wasn't the fiercest or fastest who endured, but those who could adjust, cooperate, and learn. Those who could make tools from what remained, share food, or find new ways to keep warm. Humanity's resilience was tested not in battle, but in quiet persistence, in the daily decision to keep going when the world offered little reason to believe it would get better. We can only guess at what those people thought, what they feared, what they hoped for. They had no written records, no maps, no sense of the scale of what had happened. They knew only what they could see, a colder earth, dimmer skies, and a dwindling supply of life around them. Yet somehow they endured. Some found refuge in caves or along sheltered coastlines, where temperatures stayed a little higher. Others followed the last remaining herds across wide, barren plains, travelling farther than any of their ancestors had before. The bottleneck wasn't just biological, it was cultural. Knowledge, like genes, depends on survival. When groups died, their skills and stories died with them. Languages vanished, traditions disappeared, but the small groups that remained carried forward fragments of those lost worlds. They preserved fire-making, tool-building, tracking and storytelling, the essential pieces of humanity's identity. These fragments, passed from parent to child, became the foundation of everything that would come later. The genetic evidence for this bottleneck is striking. Modern humans are remarkably similar to one another at the DNA level compared to other species. Chimpanzees, for instance, have more genetic diversity within a single troop than all humans across the globe. That uniformity hints at a time when our numbers were so low that our entire species nearly vanished. The survivors' descendants repopulated the Earth, carrying the same small set of genetic variations. Scientists studying mitochondrial DNA, passed down through mothers, have found that all humans trace back to a single common ancestor who lived around this time. Not a single woman, of course, but a population so small that their genetic lines converge easily in the record. The same pattern appears in Y chromosome studies, tracing paternal lineages. Everywhere the evidence points to the same conclusion. Humanity came close to extinction and started again from a narrow base. But this bottleneck was more than a genetic event. It was an evolutionary filter shaping who we became. The pressures of survival in a cold, uncertain world selected for traits that favoured adaptability, cooperation, and intelligence. Groups that learned to plan, communicate, and share resources fared better than those that didn't. Those abilities, honed over generations, would later define our species. The survivors of Toba's aftermath likely lived in small communities, perhaps a few dozen people at most. They would have known each other intimately. Every life mattered. Every loss felt deeply. Births were rare and precious. Death, constant and expected. The social bonds in such a world would have been intense. Trust, loyalty and shared purpose were not virtues but necessities. When survival depends on others, selfishness becomes a risk. It's possible that this period, harsh as it was, laid the groundwork for the social complexity that would later give rise to human culture. The ability to cooperate, to communicate abstract ideas, to plan for the future. These were not luxuries, they were survival tools. Around shared fires in cold caves, language may have evolved to coordinate hunting, to warn of danger, to comfort. Out of necessity came connection. In those years of scarcity, humans would have followed animals to the edges of their ranges. Some might have hunted mammoths or other large game in the colder regions. Others relied on fish or shellfish along coastlines. Each group found its own balance between the land and the changing climate. Over time, these adaptations diversified our species. As the Earth warmed again, these scattered groups expanded, carrying their knowledge and resilience with them. For scientists, tracing this period means reading the Earth's slow handwriting. Layers of ash, soil chemistry, fossilized pollen, and bones all tell fragments of the same story. In Africa, there are signs of long droughts that match the timing of the eruption. In India, stone tools lie beneath and above the Toba ash, showing continuity, proof that at least some humans endured. In Southeast Asia, traces of habitation suggest that even near the eruption, life persisted in pockets. It's difficult to overstate how unlikely that survival was. The combination of volcanic darkness, freezing temperatures, and ecosystem collapse would have been enough to erase most species. Many did disappear. Entire lineages of plants and animals ended during that time. But humans, for reasons we can only partly understand, endured. Perhaps it was flexibility, the ability to eat a wide variety of foods. Perhaps it was intelligence, the ability to innovate. Perhaps it was community, the strength found in shared struggle. Most likely it was all of these together. The bottleneck left more than physical traces, it left psychological ones too. The experience of scarcity and unpredictability may have shaped early human behaviour in ways that persist even now. The instinct to store food, to seek security, to fear loss. These may be echoes of that ancient memory, carried forward through generations. The sense of awe we feel toward nature's power, the reverence for fire, the urge to gather and protect, all of these could be seen as distant reflections of those dark years. As the centuries passed, the climate slowly stabilized. The air cleared, the sun returned, and the ice began to retreat. Populations that had been isolated started to grow again. The genetic diversity of humanity began to expand, but the imprint of that narrow origin remained. Every person alive today, whether in Asia, Africa, Europe, or the Americas, is a descendant of the few who survived that winter. The diversity of the modern world, of cultures, languages, and ideas, all stems from a single thread of continuity that passed through that moment of near extinction. The evidence for the bottleneck doesn't come from human fossils alone. It appears in the DNA of other species too. Animals that depended on similar habitats, large mammals for example, show reduced genetic variation from the same period. It's as if the whole web of life contracted, tightened, and then spread again. The Toba eruption didn't just affect humans, it reshaped entire ecosystems, pruning the tree of life and forcing it to regrow from its strongest branches. In this way, the bottleneck wasn't simply a tragedy, it was also a turning point. Without it, humanity might have developed differently, perhaps more fragmented, less unified, or less resilient. The shared struggle may have created a sense of continuity that allowed later humans to cooperate in larger numbers, to build communities that could withstand future challenges. In enduring catastrophe, the species became something new. When researchers look back at this time, they often talk about the founder effect. It's the idea that when a small population gives rise to a much larger one, the traits of those few founders shape everything that follows. Every language, every face, every idea traces back to that foundation. It's strange to think that the entire human story, art, music, science, civilization, all of it may have emerged from the descendants of a few thousand survivors huddled against the cold 74,000 years ago. But beyond genetics and history, there's something deeply human in that story. The image of small groups gathered around fires under dim skies, sharing warmth, food, and hope. That's where everything began. Every tool, every word, every step forward came from that will to survive. They couldn't have known what they were preserving, or that their descendants would one day look back and piece together their story from the stones and genes they left behind. But in their endurance, they gave us everything. The bottleneck didn't last forever. Slowly, over thousands of years, the world grew more generous again. Forest returned, animals repopulated, and rivers ran full. The survivors' descendants spread across the continents, adapting to new environments as they went. In each new land they carried the memory, perhaps unspoken but real, of what it meant to live through a world that almost ended. That memory is still with us, though it's buried deep beneath the noise of modern life. It lingers in our instincts, in our fascination with fire, in our fear of darkness, in our reverence for the planet's power. Somewhere within us is the genetic and emotional imprint of those who saw the world turn to ash and still found a way to continue. When scientists study the genetic markers of that time, they don't just see loss, they see connection, the thread that ties every human being together through shared ancestry. We're all branches of the same tree that survived the storm. Every population, every culture, every person is part of that lineage of endurance. It's a reminder that for all our differences, the foundation of who we are is the same. The Earth has moved on since then. The caldera that once exploded with unimaginable force is now filled with calm blue water. The ash that once blotted out the sun is now soil beneath forests. The people who live near Lake Toba today fish in its waters, unaware that their home rests atop the memory of a near extinction. But the planet remembers in its quiet way, through layers of rock and traces of chemical change, through the shape of its surface and the patterns of its life. And so do we, even if we don't realize it. Every breath, every heartbeat, every shared moment is the continuation of that ancient will to survive. The bottleneck that nearly ended us also defined us. It made us the species that endures, that rebuilds, that looks to the horizon and moves forward. And as the warmth returned and the forest began to grow again, the survivors stepped into a world both familiar and strange, a world waiting to be rediscovered, a planet that had quieted but not forgotten what it was capable of. The long silence after the fire had shaped everything, and now in that silence life began to speak again. When the cold finally loosened its grip, when the haze thinned enough for the sun to warm the ground again, the world that emerged was not the same one that had fallen under the shadow of ash. Forests returned in fragments, patchy and uneven. Rivers carved new paths through the hardened layers of volcanic debris. The air carried new scents, the freshness of regrowth, the sharpness of minerals newly exposed, the faint sweetness of plants reclaiming the soil. But the most profound change was not in the land. It was in the life that remained, in the bodies and minds of the survivors who had passed through the narrow gate of near extinction. Humanity had changed, though they wouldn't have known it. Change on that scale doesn't announce itself. It lingers quietly in bloodlines, in instincts, in small variations that accumulate over time. The people who had endured the cold carried something within them. Not a memory in the way we think of memory, but a biological echo. Their bodies bore the mark of survival, and that mark would echo through every generation that followed. When modern scientists look back at this time, they do so through the lens of genetics. DNA, the code of life, keeps records far older and more detailed than any written history. Within it are traces of migrations, population crashes and recoveries. The Toba eruption left its own signature there. a thinning of genetic diversity so distinct that it can still be seen in every human population today. Every cell in the body contains this record, a string of molecular letters that tell a story of endurance. When researchers compare human DNA from across the world, they find remarkable similarity. That similarity is the shadow of the bottleneck. It tells us that at some point, not long ago in geological terms, our species passed through a moment when only a small number of individuals carried our entire future. The narrowness of that moment is visible in how little genetic variation we have compared to other species. Some of the most compelling evidence comes from mitochondrial DNA, the small circular strand passed from mother to child, largely unchanged except for small, random mutations over time. By tracking these mutations, scientists can estimate how long ago populations diverged. All living humans share mitochondrial ancestry that traces back to a small group of women who lived roughly 70 to 100,000 years ago. These were not the first humans, nor the only ones alive at the time, but they were the ones whose lines endured. The same is true for paternal lineages traced through the Y chromosome, passed from father to son. These lines also converge around the same time. Together they reveal the echo of that bottleneck, the moment when humanity's genetic tree narrowed to a single trunk before branching again. Every person alive today, from every continent, carries pieces of that same root system. It's a strange thought that in every one of us are the faint traces of that ancient struggle, not as memories we can recall, but as codes written into our biology. The ability to process certain foods, to withstand certain climates, to respond to fear or stress. All of these are shaped by our ancestors' experiences. Even our brains, capable of imagination and empathy, may bear the influence of that long test of survival. The need to cooperate, to form bonds, to understand others, became more than social traits. They became part of our wiring. The echo of that time is also visible in how humanity spread afterward. As the climate stabilized, those few surviving groups began to move again. Small populations migrated outward, following the warming lands, crossing rivers and coastlines. Each migration carried a subset of the genetic variation that existed within the survivors. That's why the further you move from Africa, where the largest groups remained, the less genetic diversity you find. It's a gradual fading outward, like ripples moving away from a single point of origin. In that sense, every journey humanity has taken since is part of the same movement, an expansion from scarcity toward abundance, from cold toward warmth, from near extinction toward the complexity of life we see now. Every person alive is part of that expansion, an unbroken chain of survival stretching back through the long winter to the people who refuse to disappear. Geneticists often describe this period as a founder effect. It means that the traits of those few survivors had an outsized influence on the generations that came after. Their resilience, their adaptability, their physiological strengths became the baseline for the species. What we think of as human, our endurance, our intelligence, our cooperation, was tested and reinforced by that period of trial. Even today, traces of that echo can be seen in how populations differ slightly in their genetic adaptations. Some groups developed traits that helped them process certain foods, others adapted to cold or high altitudes. But beneath those differences, the core is the same. We are all built from the same small collection of genes that survived that ancient filter. The similarities among us are far greater than the differences. For scientists, studying this genetic echo isn't just about understanding the past, it's about understanding how life responds to catastrophe. The Toba bottleneck shows that even when a species is reduced to the edge of extinction, recovery is possible. Evolution doesn't stop, it adapts to new realities. The world that followed Toba's eruption was a harsh one, but it also offered new opportunities. The survivors spread into empty niches, filling the spaces left behind by lost species. The planet, scarred but alive, became a blank page again. It's easy to imagine that the echo of that time might be more than genetic. Some part of it may linger in our collective psychology. the quiet knowledge that the world can change overnight, that survival depends on adaptability, that cooperation is stronger than isolation. These instincts might be ancient responses passed down through stories before there were languages, through behaviour before there were words. The fear of the dark, the reverence for the sun, the comfort of gathering near fire. All of these might be echoes of a time when those things meant the difference between life and death. When people today look up at the stars, it's tempting to feel separate from that ancient world. We live surrounded by the creations of our own making, far from the simplicity of the small groups that once walked the ashen plains. But genetically, emotionally and biologically, we are still them. The same resilience that carried them through the cold carries us through every uncertainty. The same curiosity that drove them to explore new lands drives us still, though our journeys now reach beyond the planet itself. In a way, the echo in our DNA is a conversation between past and present. It's the body remembering what the mind cannot. When we respond to danger with heightened senses, when we seek comfort in warmth, when we build communities for safety, those are the old patterns reasserting themselves. They were carved into us during those years when the earth was dark, when survival meant unity. The genetic record also tells us about timing, when humanity began to recover and expand. After the eruption, it may have taken tens of thousands of years for populations to reach pre-eruption numbers again. During that time, humans continue to evolve culturally. Toolmaking advanced, art began to appear in primitive forms, and migration accelerated. The species that had once huddled around sparse fires became explorers again. The echo of the bottleneck was still there, but it was accompanied now by a growing diversity of expression and creativity. This recovery period is visible not just in DNA but in the archaeological record. The spread of stone tool technologies, the use of pigments, the building of more complex shelters, all of these appear after the bottleneck period. It's as if, once the threat of extinction passed, human innovation surged. The same minds that had adapted to survival in scarcity began to imagine beyond it. Perhaps the memory of loss made them value creation more. Even language may have been shaped by that period. Communication would have been essential for survival. Coordinating hunts, sharing food, comforting the sick. Those who communicated more effectively had better chances of keeping their groups alive. Over generations, that selective pressure could have refined our capacity for language, turning it into the powerful tool it became. The echo of the bottleneck might also explain why humans seem uniquely aware of their vulnerability. Unlike most species, we contemplate extinction. We build stories about it. We prepare for it. That awareness could be the inherited trace of a time when extinction was not an idea, but a lived reality. Our fascination with apocalyptic stories, our instinct to plan for the worst, our fear of the unknown, all of these may come from that distant trauma, carried forward through generations. There's another layer to the echo, one that speaks less to science and more to perspective. When we realise that every human being shares ancestry from a single population, the divisions that define us, race, nation, belief, begin to look small. The differences we see are surface details, shaped by geography and time. Underneath, the same survival story runs through us all. The same genetic thread connects the people of every continent, every culture, every language. We are the children of the same narrow chance. That understanding carries both humility and wonder. Humility because it reminds us how close we came to vanishing. Wonder because it shows how much we've become since then. From a few thousand survivors in a cold, grey world, humanity grew into billions of individuals capable of exploring the depths of space and the intricacies of life itself. The echo of that near extinction is not one of despair, but of resilience. If you were to look at the double helix of DNA and think of it as a song, the Toba bottleneck would be a pause, a quiet measure between two movements. Before it, The melody of life was wild and unstructured. After it, the rhythm changed. Tighter, more focused, carrying the memory of silence within it. Everything since then, every birth, every thought, every step forward, has been part of that new rhythm. But the Earth too carries echoes of that same event. The ash layers in sediments, the traces of sulfur in ice cores, the altered patterns of species distribution. All of it mirrors the genetic record in its own language. It's as if both planet and people remember the same trauma differently. The Earth in stone and ice, humanity in code and instinct. The relationship between the two has always been one of reflection. The planet changes, and life responds. The eruption reshaped the climate reshaped us. In that way, the Toba eruption is not just part of our past, it's part of what made us human. It taught the species the lesson every generation still learns, that survival depends on adaptation, and adaptation depends on connection. Even now, when we look at the world's changing climate, or at the restless volcanoes still sleeping beneath the Earth's crust, we are looking at the same forces that shaped us. The magma still moves beneath our feet. The gases still rise, the crust still shifts. The Earth's cycles haven't ended. We've just learned to live within them, for now. And so, the echo in our DNA is more than a reminder of what was lost. It's proof of what was gained, the ability to survive the unimaginable, to rebuild, to learn, and to pass those lessons forward. It's the quiet resilience that still hums beneath the noise of modern life, the unspoken knowledge that we are all the descendants of survivors. Somewhere inside that code, in the patterns of our cells, in the instincts that guide us, the memory of that time remains. It's not something we can recall consciously, but it's there, steady and silent, like a heartbeat that never stopped. The Earth remembers through stone. We remember through blood. Both carry the same story, of a world that nearly ended and of life that refused to yield. And as the survivors of that ancient age began to rebuild, spreading outward once again, their story continued into the one we live now, still written in every living thing that walks the planet they left behind. The Earth remembers everything. It keeps its memories in places that move too slowly for us to notice. In stone, in ice, in sediment, in the quiet spaces between layers of time. Every grain of ash, every trapped bubble of air, every mineral that settled to rest is part of a record that never stops writing itself. While we measure time in years, the planet measures it in accumulation. Each new layer builds upon the last, pressing gently down, sealing the story of what came before. Long after the survivors of the Toba eruption had moved on, and the forests had grown back, the evidence of that ancient event remained buried just beneath the surface. The ash that had once fallen like a storm hardened into tuff, compressed into rock by the weight of all the seasons that followed. It formed distinct bands in the Earth's crust, pale, even layers that can still be traced across continents. These layers are like bookmarks in the story of the planet, reminders of moments when everything changed. Scientists studying these layers can read the Earth's history with a precision that borders on impossible. They drill deep into the ground, extracting cores of sediment that span thousands, even millions of years. Within each section, there are tiny clues, variations in colour, texture, and composition. A thin grey band might mark a volcanic eruption. A darker one might signal a time of flood or drought. Each band represents not a single event, but the slow passage of time, compressed until it becomes tangible. In the case of Toba, the evidence stretches far beyond Sumatra. Layers of ash matching the eruption's chemical fingerprint have been found across South Asia, East Africa, and even in the depths of the Indian Ocean. Each discovery confirms how far the eruption's reach extended. It's one thing to imagine ash drifting through the sky, another to find it solidified in rocks half a world away. The same material that once blotted out the sun now lies quietly beneath the ground, unchanged but telling everything. To identify these layers, scientists compare the trace elements within them, the specific proportions of silicon, iron, aluminum and rare minerals that act like a signature. No two eruptions produce the same exact mixture. The Toba layer, rich in silica and volcanic glass, is instantly recognizable. When geologists find it, they know exactly when they are in time, 74,000 years ago, a fixed moment in the planet's long memory. Above that layer, life continues. Below it, a different world. It's as if the Earth itself marked the event, dividing before and after with a line of stone. But while the surface changed, forests grew, climates shifted, oceans rose and fell, the memory of the eruption stayed intact. Rock doesn't forget easily. Once sealed beneath new layers, it becomes part of the planet's deep archive. The same is true for ice. At the poles, where snowfall never fully melts, the Earth's atmosphere is preserved in frozen form. Each year, a new layer of snow compresses the one beneath it, trapping tiny bubbles of air inside. Over thousands of years, those layers become ice, and those bubbles become records of the air itself. Tiny, perfect samples of past atmospheres. When scientists extract ice cores from Greenland or Antarctica, they're essentially reading a diary of the planet's climate. The deeper they go, the further back in time they travel. Each layer contains not just frozen water, but traces of dust, volcanic ash, and chemical isotopes that reveal temperature, precipitation, and even levels of greenhouse gases. In the ice, Toba's eruption appears as a thin, distinct layer, a slight spike in sulfur and ash content, a chemical scar marking a brief but enormous disruption. The air trapped above and below it shows a sudden drop in temperature, confirming what geology had already suggested, that the world grew colder after the eruption. The match between stone and ice is precise, two separate memories telling the same story in different languages. What's remarkable is how stable these records are. Ice and rock hold their secrets for tens of thousands of years, untouched by the chaos of the surface. Storms, floods, earthquakes, they reshape the land. But deep within the ice sheets or far below the soil, time moves differently. There, nothing rushes. The molecules settle into place, and the planet's past remains preserved until someone comes to read it. The process of reading it requires patience and precision. Scientists melt small sections of ice to release the trapped air, analysing the gases with instruments capable of detecting differences of a few parts per million. They measure isotopes of oxygen and hydrogen to estimate temperature. They identify the presence of sulfur compounds that trace back to volcanic eruptions. Each detail adds a piece to the puzzle. Together, these records build a clear picture of the world as it was. They show the abrupt cooling after Toba, followed by a slow, uneven recovery. They reveal the fluctuations in carbon dioxide that accompany the changing climate. They show how rainfall shifted and how the polar ice expanded. It's a level of precision that allows scientists not only to understand what happened, but to model how the Earth might respond to future events. The Earth's memory isn't limited to physical records. It also resides in the chemistry of the oceans, in the sediments that settle at the bottom of lakes, and in the composition of coral reefs that grow one thin layer at a time. Every system that accumulates material over time becomes an archive. Each has its own timescale. Coral remembers centuries, lakes remember millennia, ice remembers ages. In the sediments of ancient lakes near the site of the eruption, researchers have found layers of ash and organic matter that alternate like the pages of a slow story. The ash marks destruction, the organic layers mark recovery. Each alternation shows life returning, only to be interrupted again by another pulse of volcanic activity or climatic shift. It's not a simple story of catastrophe and renewal, but one of constant balance and adjustment. By studying these layers, scientists can reconstruct not only the eruption itself, but its impact on ecosystems. Pollen grains trapped in the sediments reveal which plants grew before and after. Some disappeared entirely, others thrived in the new conditions. the data suggests that while the eruption devastated many regions, it also created opportunities for new life to emerge. The ash enriched the soil, and the cooling reset ecological systems, allowing species adapted to colder climates to expand. Even microorganisms record these changes. In marine sediments, scientists find shifts in the species of plankton that lived during the cooling period. Some types vanish from the record, replaced by others that could tolerate lower temperatures or reduce sunlight. The smallest forms of life, invisible to the eye, leave behind evidence of adaptation just as clearly as the rocks and ice do. All of these records, scattered across the planet, tell the same story from different perspectives. The Earth remembers what happened to it in a way that's both simple and profound. Each environment, stone, ice, water, holds its own version of the truth. When those truths are combined, they form a complete picture of a moment when the planet changed and then carried on. The idea that the Earth has memory is more than metaphor. It's a scientific reality. The cycles of erosion, sedimentation, and glaciation are nature's way of keeping records. What we call geology is, in essence, the study of that memory. Each layer is a data point, each fossil a photograph, each isotope a word in a story that spans billions of years. The Toba eruption is just one chapter, but it's one of the few where the traces of destruction and recovery are visible everywhere at once. It's humbling to think that long before humans could write or record, the Earth was already documenting its own history. Every raindrop that fell into cooling ash, every snowflake that trapped a particle of dust, every ripple of sediment that covered the remains of plants and animals, all of it was a form of writing, though it would take us tens of thousands of years to learn how to read it. When scientists first began to find evidence of Toba's eruption in ice cores and sediments far from Indonesia, it changed how we understood global systems. It proved that the Earth's atmosphere connects everything, that a single event in one place can ripple across the entire planet. The ash that fell in Africa came from a mountain in Sumatra. The cooling in the Arctic was caused by gases released in the tropics. The entire planet is one body, and every part of it feels the same heartbeat. Even now, new discoveries continue to refine our understanding. Satellite imagery helps map the extent of the ancient ash deposits. Isotopic analysis provides more accurate dating. Each refinement adds clarity to a story that began in fire and ended in ice. Yet, for all the detail science provides, there's still something awe-inspiring about how simple the core truth remains. The planet remembers. It carries forward the record of every eruption, every storm, every shift. And in that continuity lies the key to understanding not just what happened, but what might happen again. The stones beneath our feet are older than any civilization, older than any species alive today. The ice at the poles holds air that no human ever breathed, but that shaped the world we inherited. When we touch these things, we're not just touching material, we're touching time. The minerals and molecules within them are the same ones that existed when the Toba eruption darkened the sky. They've moved through cycles of life and decay, melted, solidified, and returned again. If you think about it long enough, the distance between past and present begins to blur. The carbon in our bodies once existed in the atmosphere that cooled after Toba. The oxygen we breathe now has passed through countless generations of life since then. The calcium in our bones may once have been part of the shells of plankton that lived in the ocean as the Earth recovered from the eruption. The line between history and existence is thin. What makes the study of these ancient records so remarkable is not just what they tell us about the past, but how they connect us to it. Every measurement, every discovery, every analysis is a conversation with the planet's memory. When scientists extract a core sample from a glacier or a deep-sea sediment, they're holding a timeline that predates humanity, but still includes us. We are part of that record now, our actions leaving new layers for future generations to study. The Earth doesn't judge what it remembers. It doesn't distinguish between beauty and destruction, between creation and loss. It simply records. The same mechanisms that preserve the story of Toba are preserving ours. The carbon we release, the plastic we leave behind, the changes we make to the atmosphere, all of it is becoming part of the planet's memory. It's a reminder that nothing is ever truly forgotten. The eruption that almost ended humanity still lives in the rock, in the ice, in the genes of every living person. The connection between all those forms of memory, geological, biological, atmospheric, creates a continuity that links the distant past with the living present. The world remembers what we often forget, that survival and change are the same thing, that every ending leaves behind the materials of a new beginning. Somewhere deep beneath the calm waters of Lake Toba, the layers of cooled lava and compacted ash rest undisturbed. They are the closest thing we have to a photograph of that day. Every grain is a record of heat and pressure, every fissure a frozen instant of motion. The earth has sealed it all beneath stone, waiting, not for rediscovery but for time to pass. The lake above it is the surface of that memory, tranquil, reflective, unhurried. When we study the past, we're really studying the planet's way of remembering, and the more we learn, the clearer it becomes that the Earth is not separate from us. Its memory is our inheritance. Its resilience is our story. Its cycles of destruction and renewal are mirrored in everything we've become. And so, as the world warmed again and life spread outward once more, the records of that ancient eruption remained quietly beneath the surface, a steady heartbeat in the deep archives of the planet, waiting for a species curious enough to listen. The Earth doesn't speak in words, but it teaches in patterns. Every eruption, every earthquake, every slow shift of the crust is part of a conversation that has been going on since the planet first cooled. When we study a volcano like Toba, we're not just examining a natural event, we're listening to a message written in heat and silence. The lesson isn't about fear or even survival, it's about scale, about how the forces that shape the world move on timescales so vast that human history fits inside them like a single breath. Toba still sleeps, but it's not dead. Beneath the calm waters of Lake Toba, the magma chamber that once tore open the sky still exists, slowly refilling, slowly shifting. It's easy to forget that supervolcanoes don't disappear after they erupt. They rest. The Earth seals their wounds, cools their surfaces, and hides their power under new layers of rock and water. The surface becomes peaceful again, covered with forests and villages, but the system below remains alive. The magma moves, gases rise, the crust flexes. It's quiet but never still. Scientists have learned that supervolcanoes like Toba operate on a rhythm measured in tens or hundreds of thousands of years. They fill and empty like the tides of the deep earth. Each cycle of pressure and release creates the landscapes we see today. Calderas that become lakes, lava that becomes mountains, ash that becomes soil. The planet renews itself through destruction. It's not a cycle meant for us. It's simply how the world works. But understanding that rhythm changes how we see ourselves. When humans first began studying volcanoes seriously, they saw them as isolated phenomena. Dangerous, yes, but local. Only in the last century did we begin to realize how interconnected these systems are, and how a single eruption can ripple across the globe. The lesson of Toba is that the Earth is one continuous system. The crust, the atmosphere, the oceans, all of it responds to the same forces. When one part moves, the rest follows. Modern instruments allow scientists to monitor this movement constantly. Satellites measure ground deformation, detecting when land swells or sinks by mere centimeters. Seismic sensors record the faint tremors that travel through the crust, the whispers of magma moving far below. Gas monitors capture the release of carbon dioxide and sulfur dioxide, clues that pressure is building. Together, these observations form a language, one we've only recently learned to read. What they show is that Toba still breathes. The lake's floor rises and falls slightly over the years, expanding and contracting as magma shifts beneath it. Occasionally small earthquakes ripple through the region, reminders of the restless power below. None of these are signs of imminent eruption, but they are evidence of life. The volcano sleeps lightly. To study a system like Toba is to confront time in its rawest form. The last supereruption was 74,000 years ago. The next might not come for hundreds of thousands more. Our entire recorded history, all of human civilization, fits between those intervals like a brief pause. When we measure our lives in days and decades, it's difficult to comprehend something that measures in millennia. But that's what the Earth does. It waits. It moves at a pace beyond anxiety or urgency. The lesson isn't about predicting the next eruption. It's about humility. The same ground we walk on without thought is the surface of an active system, dynamic and alive. We live on the skin of a planet that is constantly remaking itself. That knowledge can be unsettling, but it's also grounding. It reminds us that permanence is an illusion, that everything solid was once fluid, and everything calm was once chaos. Volcanoes, especially the largest ones, are often framed as threats. They are in a way, but they're also creative forces. Without volcanic activity, the Earth would be a cold, lifeless world. The gases that once poured from ancient vents formed our atmosphere. The minerals in volcanic rock feed the richest soils on the planet. Many of the islands and mountains we call home exist because of eruptions long past. Destruction and creation are inseparable. The same eruption that once covered continents in ash eventually made those lands fertile again. Toba's story is a clear example of this duality. The eruption nearly ended humanity, yet the aftermath laid the foundation for renewal. The ash that poisoned the air eventually nourished the forest that returned. The climate disruption that caused hardship also reshaped ecosystems, leading to new evolutionary paths. The people who survived emerged stronger, more adaptable, more connected. The volcano's destruction was also its lesson, that life depends on the same forces that can take it away. Modern science views supervolcanoes through data and models, but there's a deeper wisdom in what they represent. They remind us that we are temporary guests on a planet that doesn't belong to us. Our cities, our technologies, even our species are brief episodes in a much longer story. The Earth has endured ice ages, impacts and extinctions, and each time it's found equilibrium again. We exist because the planet is capable of that balance. The challenge for us is not to control these forces, we can't, but to understand them, to live within their patterns instead of against them. Toba teaches that the greatest danger isn't the eruption itself, but forgetting that such things happen. The illusion of stability is comforting, but it's also fragile. The Earth's surface has always been temporary. Every mountain, every coastline, every fertile valley is the product of movement. Recognizing that doesn't diminish their beauty, it deepens it. In Indonesia, near the shores of Lake Toba, people live normal lives. They farm, fish, and raise families on the edge of one of the largest volcanic systems on Earth. Most don't think about the magma below. The caldera has been peaceful for so long that it's simply part of the landscape. The lake's blue surface reflects clouds, and the hills are covered in trees. It's a place of quiet beauty built on the memory of unimaginable violence. That contrast, calm above, energy below, captures something essential about the planet. It never truly stops. There are other sleeping giants like Toba scattered across the world. Yellowstone in North America, Taupo in New Zealand, Campi Flegrei in Italy. Each one is monitored, studied and modelled. Each one has its own rhythm, its own slow breathing pattern beneath the surface. The lesson they share is the same. Earth's power is continuous, and human time barely registers against it. The world we know could change in an instant, not because of malice or randomness, but because that's what the planet does. When people hear about supervolcanoes, they often imagine sudden apocalypse, cities buried in ash, skies darkened for years. But reality moves differently. The build-up to such an eruption would take thousands of years, and even then it might release in smaller events instead of one massive one. The systems that drive these eruptions are complex, and while they hold potential for destruction, they also demonstrate stability. The Earth doesn't explode at every sign of tension. It adjusts, flexes, releases, and continues. That steadiness is another lesson. The same planet that can tear itself open also spends most of its time in balance. Volcanoes, earthquakes, storms, these are interruptions in long periods of calm. The majority of the Earth's history has been quiet enough for life to flourish. Even after catastrophic events, the recovery is often faster than we expect. Life returns, ecosystems adapt, the planet finds its equilibrium. To understand Toba is to understand both danger and resilience. The eruption was vast beyond imagination, but it didn't end life, it tested it. And in that test, life proved stronger than we might have thought possible. The survivors, human and otherwise, became the ancestors of everything that followed. The memory of that endurance is written in stone, in DNA, and in the quiet persistence of forests that grow where fire once raged. The people who live near volcanoes today understand something that modern cities often forget, that the Earth is alive. In those regions, the smell of sulfur or the rumble of distant tremors isn't unusual. It's part of daily life. The soil is rich, the air humid, the landscape constantly renewing itself. Living near a volcano means living close to creation. The danger is real, but so is the fertility it brings. It's an exchange, one that humanity has made for thousands of years. In some ways, that relationship mirrors the one between humans and the planet itself. We draw from it, shape it, and depend on it, often forgetting that it's not a stable foundation but a dynamic, evolving system. Toba, quiet as it seems today, is a reminder written into the landscape that change is inevitable. Beneath the calm, there's always motion. Beneath the stability, there's always potential. When scientists measure the gases rising from the lake, or map the small tremors beneath its floor, they're not predicting disaster. They're listening. Each reading, each vibration, is a word in the planet's language. Most of the time, that language says, "I'm alive." Only rarely does it say, "I'm changing." And even then, change doesn't mean destruction. It means transformation, a continuation of the same rhythm that has always defined the Earth. That's perhaps the quietest and most important lesson of Toba. Catastrophe is part of the same process as creation. The world renews itself through cycles that are bigger than fear. Our place in that cycle is small, but it's not meaningless. We are one expression of the planet's capacity to adapt. We carry its history in our cells, its minerals in our bones, its chemistry in our breath. When the Earth moves, we move with it, whether we realize it or not. Toba reminds us that what seems destructive is often just a form of rebalancing. The eruption released pressure that had been building for millennia. Without such releases, the planet's crust would become unstable. In its own way, the eruption maintained the Earth's equilibrium, even as it disrupted life on the surface. The scale is difficult to accept, but it's also comforting in a strange way. It shows that even in apparent chaos there is order, a slow, natural logic that has sustained the planet for billions of years. The Earth doesn't hurry, and it doesn't forget. The same energy that created the eruption still circulates beneath the crust, slowly moving, shaping the continents, feeding other volcanoes, raising mountains. The heat of the planet's core is constant, generated by the decay of ancient elements that have been releasing energy since the beginning of time. The surface cools, but the interior never stops burning. That contrast, fire within, calm without, defines everything we see. If you stand on the rim of Lake Toba today, you see serenity. The wind moves softly across the water. The hills rise green and gentle. The sound of waves against the shore replaces the memory of roaring fire. But the rocks beneath your feet tell a different story. Their texture, their composition, Their layering all record the violence that once shaped this place. The lake's stillness isn't denial, it's recovery. The volcano isn't gone, it's resting. And perhaps that's the final unspoken lesson, that rest and renewal are not opposites, but part of the same process. The Earth's quiet periods are not absence but preparation. Beneath every calm surface is motion. Beneath every silence is energy. The same planet that once tore itself open now holds still, reflecting sunlight off its calm waters, waiting for its next slow breath. We are, in every sense, living on borrowed calm. That doesn't mean we should fear what lies below. It means we should listen, respect, and remember. The ground beneath us is not just support, it's story. Every step we take, every field we plant, every home we build stands on the memory of the planet's movements. Toba's lesson isn't about destruction, it's about continuity, that even in the most violent transformation, the Earth remains whole, and life finds a way to grow again on its surface. And as magma still moves quietly in the depths below, the lake above it reflects the passing clouds, the light and the sky. All temporary, all beautiful, all part of the same vast, patient rhythm that has been teaching since the beginning of time. The Earth has always balanced on a fragile thread, even if it never seems that way from where we stand. To us the world feels solid, enduring, permanent. The ground beneath our feet, the air we breathe, the water that fills our lakes and seas. But everything that feels stable is the result of constant motion, invisible and unending. The crust shifts, the air changes, the oceans breathe in and out with the pull of the moon. What we call balance is really just motion that happens slowly enough to feel like stillness. After Toba, that balance took a long time to return. The climate steadied, the forests regrew, and life resumed its slow expansion. But the memory of what happened was written everywhere, in the rocks, in the ice, in the genes of everything that survived. The eruption had been a moment of reset, one of the rare times when the Earth reminded itself, and everything on it, that stability is temporary. The planet doesn't cling to the way things are. It changes, it adapts, and then it continues. For humanity, that realization came much later. Thousands of generations passed between the eruption and the first time humans understood what volcanoes truly were. For most of our history, they were seen as the mouths of gods or the wrath of unseen forces. We felt the ground tremble and assumed it was anger, not physics. We saw fire rise from the earth and called it punishment. It took us most of our existence to see volcanoes not as divine acts, but as the planet's natural exhalations. That understanding is still new. Modern science has only just begun to grasp how deeply connected everything is. We now know that the gases from eruptions shape our atmosphere, that the ash enriches the soil, that the same minerals forged in magma become part of our own bodies through the food we eat. The same heat that destroyed life after Toba also created the chemical conditions that allowed new life to thrive. It's a cycle that never ends, even if our minds can barely contain its scale. The fragile thread that connects us to the future is built from that same cycle. We exist because the Earth found balance after catastrophe. Our survival depends on that balance continuing, but balance, as the planet shows us, is never static. It's the result of countless forces pulling in different directions, always moving, always recalibrating. The atmosphere absorbs gases and releases them. The oceans store heat and return it. The crust bends, cracks, and heals. Every part of the Earth participates in this negotiation. Humanity has become another one of those forces. We've changed the composition of the atmosphere, altered the flow of rivers, reshaped coastlines, and moved mountains. For the first time, the planet's surface carries the marks of a species that can change it knowingly. That makes our thread to tomorrow even thinner. Not because the planet is fragile, but because our presence within it is. The Earth will endure whatever happens. The question has always been whether we will. If Toba teaches anything, it's that the line between survival and extinction is narrow. Life can be reduced to a handful of survivors, yet still find a way to return. But that recovery takes time. Time measured in tens of thousands of years. When humans think about the future, we often imagine centuries, maybe a millennium. The planet thinks in millions of years. What feels permanent to us is a moment to the Earth. Looking back at Toba from our vantage point now, the lesson feels both comforting and unsettling. Comforting because it shows that life is resilient beyond measure. Unsettling because it shows how easily that resilience can be tested. We live in an age where the planet is changing again, not from a volcano, but from us. The gases that once filled the sky after Toba, carbon dioxide, sulfur, methane, are now rising for different reasons. The temperature shifts, the ice melts, the weather patterns change. The rhythm is familiar, even if the cause is new. Scientists studying ancient climate events often look to Toba for perspective. The eruption caused a global winter that cooled the planet for years. Today, the concern is the opposite. A warming that accelerates faster than anything the Earth has seen in millennia. The same interconnected systems that spread Toba's ash across the world now spread our emissions. The difference is that this time, the source isn't hidden beneath the crust. It's us. That realization carries a quiet irony. For most of human history, the planet shaped us. It dictated where we could live, what we could grow, and how we survived. Now, we shape it in return. Our technology has given us the ability to influence the climate, the oceans, and even the chemistry of the atmosphere. But the same rules still apply. The Earth responds to imbalance the same way it always has, by finding a new equilibrium, even if that equilibrium excludes what came before. The fragile thread of tomorrow depends on whether we understand that. It's not about stopping change, that's impossible. It's about changing how we live within it. When the Toba eruption ended, the survivors didn't rebuild the world as it was. They adapted to the new one. They moved, learned, and found new ways to survive. Their success came not from control but from adjustment. The same lesson applies now. When we look at the present, it's easy to see ourselves as separate from those ancient survivors. We have cities, technology, and vast systems of energy and information, but beneath all of it, the same dependence remains. We still rely on the thin layer of atmosphere for air, on the balance of oceans for temperature, on the crust for stability. The planet is vast, but our place within it is small. The thread we walk is as delicate now as it was then. The Earth doesn't ask for care or respect. It doesn't require belief. It simply responds. The same physics that once lifted ash into the stratosphere now governs the circulation of carbon and heat. The difference is that this time we can see it happening. We can measure the consequences, understand the mechanisms, and still struggle to act with the patience the planet demands. What Toba shows more than anything is that survival depends on awareness. The people who lived through that eruption didn't need to understand magma or aerosols to adapt. They just had to recognize what was changing and move with it. Awareness guided them through a crisis they couldn't control. For us, awareness means something larger, a recognition that we are part of the same system, bound by the same laws and reliant on the same stability that the Earth provides. The idea of a fragile future isn't meant to inspire fear. It's meant to inspire attention. The planet has survived greater shocks than any we could cause. It has frozen and burned and flooded and healed. But the systems that sustain us, the thin layer of warmth, the balance of oxygen and carbon, the predictable rhythm of seasons, those are delicate. They exist within a narrow range, and it's within that range that we've built everything we know. When that balance shifts, life doesn't end. It changes. The world after Toba wasn't empty. It was different, Species evolved, climates shifted, and eventually a new equilibrium emerged. The same will happen again no matter what we do. The real question is whether humanity will be part of that next balance or only part of its memory. In a way, the planet has always tested its own creations. Extinctions come and go. Species rise and vanish. Each time, the survivors redefine what life on Earth means. The eruption at Toba was one of those tests, a narrowing of possibility followed by an explosion of new forms. The future we're moving into now is another test, though this time the cause is within us. But there's reason for hope in that. The same intelligence that allows us to alter the world also allows us to understand it. We have the ability to observe, predict, and adapt faster than any species before us. The challenge is not knowledge, but humility, to remember that we're not above the Earth systems, only part of them. When you think about the thread that connects the past to the future, it helps to remember how much has already passed through it. The magma that once erupted from Toba now lies quiet beneath a lake. The ash that once darkened the sky feeds the soil of new forests. The descendants of the survivors now live across every continent, carrying the same genetic legacy that began in that darkened world. The thread has stretched, tangled, and frayed, but it has never broken. That continuity is the planet's quiet gift. It doesn't guarantee permanence, but it allows possibility. The same resilience that rebuilt the world after Toba still exists in everything alive today. The forests that regrew, the animals that adapted, the humans that learned, all of them are proof that life, when given even the smallest chance, will return. Our future rests on that same resilience, but also on awareness. The fragile thread isn't meant to hold forever on its own. It depends on balance, on feedback, on respect for the scale of the systems that support it. When we ignore those systems, they correct themselves without hesitation. The planet doesn't negotiate, it recalibrates. The lesson of a sleeping volcano is not that we should live in fear of eruptions. It's that we should remember how easily the world can change and how dependent we are on its calm. Every quiet day, every predictable season, every stable harvest is part of a delicate equilibrium. It's easy to take that for granted when the sky's clear, but somewhere beneath every landscape there's motion. If the Earth's memory is written in stone and ice, then our memory is written in action. The choices we make now will become part of that record. The carbon in the air, the plastic in the oceans, the changes in temperature, all of it will be preserved in layers of future rock. Just as we study Toba's ash to understand the past, some distant generation, if it exists, will study the traces we leave behind to understand what happened here. That realization isn't a warning so much as an invitation. To see ourselves as participants in the same ongoing rhythm, to understand that the future isn't separate from the present, but made from it. The fragile thread of tomorrow runs through everything, from the magma below the crust to the air above the clouds. It connects the deep time of the earth with the brief time of our lives. And just like those early survivors who walk through the ash and cold, we too live within that thread, held by forces larger than we can see, but sustained by the same will to endure. The earth continues to move, to breathe, to change. The question, as always, is whether we can learn to move with it. The air that once carried fire now carries mist. The same winds that once spread ash across oceans now move quietly through trees that weren't yet imagined when the sky turned dark. The world, as it is now, feels calm because it has learned how to be. Every rock, every drop of water, every breath of air has passed through chaos to reach stillness. When you look at the surface of a lake like Toba, you're not just seeing reflection, you're seeing recovery that has taken 74,000 years to learn how to be silent again. The lake is wide, stretching so far that the opposite shore seems softened by distance. Its water is deep, layered over the very caldera that once tore open and reshaped the land. Beneath it lie the scars of pressure, heat, and collapse. Thick sheets of hardened magma and ash turn to stone. The surface, however, gives no sign of what lies beneath. It moves gently in the wind, rising and falling in a rhythm so small it's almost invisible. That quiet movement is what the earth becomes after it heals. It's not still, it's steady. The forests surrounding the lake are thick again. Birds call from branches. The air smells of soil, moisture, and the faint trace of volcanic minerals that feed the roots of the trees. The ground is fertile in ways that only destruction can create. The same ash that once blocked sunlight now enriches the land, allowing new life to thrive. It's one of those contradictions the planet repeats over and over, that creation and renewal often come from what once seemed like endings. The people who live near the lake now have built homes and farms along its edges. They plant rice, tend livestock, and fish in the calm water. They walk paths that follow the ridges of the caldera, unaware that those ridges mark the rim of one of the largest volcanic scars on Earth. The land has stopped speaking in the language of eruption, and now speaks in the language of growth. To live here is to live on top of the memory of fire, though no one thinks of it that way anymore. Every now and then, small tremors ripple through the region. The ground shakes, just enough for people to notice, then stops. The scientists who monitor the lake know what it means. Small adjustments, natural settling, magma moving deep below. Nothing unusual. The planet is simply breathing. To those who live here, it's just part of life. They feel the earth move and go on with their day. The sense of danger that might once have defined this place has been replaced with trust, not in safety, but in rhythm. When you think about the time that has passed since the eruption, it's easy to forget how long the planet has been at this work. 74,000 years is barely a blink to the Earth. The magma chambers that feed Toba's quiet rest are still connected to the planet's deep heat, the same energy that has burned since the beginning. Nothing truly ends here, it only changes form. The gases that rose during the eruption are still in the atmosphere, dispersed but present. The minerals that fell as ash are now in the soil, the rivers, the bodies of plants and animals. The cycle never stopped, it just slowed. To study the Earth is to realize that stillness is never what it seems. Beneath the calmest lake there is motion. Beneath the most solid rock there is tension. The planet's peace is built from layers of movement that balance one another. It's an old balance, and it has survived storms far greater than anything we've known. That understanding doesn't make the Earth less mysterious, it makes it more alive. When people visit Lake Toba today, they often describe the place as peaceful. There's a quiet that feels different from other quiets, not empty, but full, as if the air itself is listening. The wind moves across the surface of the water, carrying with it a faint mineral coolness. The hills rise around it like walls of memory, softened by forest and time. To sit by that water is to sit with something ancient, something that doesn't need words. It's hard to imagine, looking at it now, that this calm came from one of the most violent events in the planet's history. The eruption's force changed the climate, altered ecosystems, and almost ended humanity. But the world that followed found a way to begin again. The forest grew, the species returned, the air cleared. The same cycle that has always defined the Earth repeated itself. Destruction, recovery, renewal. The pattern is old, but never predictable. It's what keeps the planet alive. Humanity, too, has learned from that pattern, even without realizing it. Every civilization that has ever existed has lived between moments of calm and disruption. The difference now is that we understand the scale. We can see how thin the balance is, how dependent we are on forces that lie far beyond our control. Yet we live on, confident in our small routines, trusting that the ground beneath us will hold. The trust isn't misplaced. The earth will hold, but it will also move, and when it does, we will adapt again, as we always have. The quiet after the storm isn't silence, it's resilience. It's the sound of the world remembering itself. The lake at Toba is not an end. It's an ongoing process of equilibrium. Water fills the space where fire once was. Life grows where there was none. The cycle continues not because it has to, but because that's what the earth does. It continues. It adjusts. It survives. If you look closely, you can see reminders of the eruption hidden in plain sight. The rocks near the shore are made of compacted ash, their surfaces rough but solid. Some have patterns, tiny bubbles frozen in stone, the last breath of gases that once roared into the sky. The sand on the beaches glitters faintly in sunlight because of volcanic glass, shards so small they feel like dust. The air smells faintly different here, as if carrying traces of the planet's deep core. Everything around the lake is part of that same continuity, transformed but unmistakably connected. To stand here is to feel both small and steady. The scale of time that stretches behind this place is beyond imagination. Yet it includes us. We are part of it, even if only for a short while. The same atoms that once formed clouds of ash are now in our lungs, our bones, our breath. The same water that once boiled from the eruption's heat now falls as rain on forests and feeds rivers that run to the sea. Nothing is lost. It only changes form. In that sense, the quiet after the storm is not an ending but a reminder. It reminds us that peace isn't the absence of change, it's the acceptance of it. The survivors of the eruption may have understood that in their own way. They didn't rebuild the world as it was. They adapted to what it had become. Their resilience wasn't about conquering nature but moving with it. That adaptability, carried forward through thousands of generations, is the reason we are here now. The planet doesn't promise safety, but it offers continuity. It teaches through repetition. Every earthquake, every eruption, every flood is part of the same conversation. The words change, the tone shifts, but the meaning stays the same: balance, movement, renewal. The quiet isn't the opposite of the storm, it's what comes when the storm has done its work. When scientists measure the gases rising from the lake today, they find traces of the same chemistry that shaped the eruption. Carbon dioxide, sulfur and methane bubble up in small amounts, reminders of what lies below. These are normal signs. The planet's small exhalations, nothing more. The volcano rests, but it doesn't sleep in ignorance. It knows in its own way that time will bring pressure again, and one day, perhaps long after we are gone, it will breathe out once more. To live on Earth is to live within that rhythm. We are born into a world that has already endured countless cycles of destruction and renewal. We grow, build, and dream on land that was once fire and will be again. The certainty of that should not bring fear, but perspective. Every calm moment, every breath of air, every sunrise exists because the planet found balance after chaos. That's what the quiet after the storm really is. The balance between what was and what will be. In the evenings around Lake Toba, when the sun begins to set, the light turns soft. It spreads across the water in wide bands of gold and grey. The surface reflects everything but holds nothing. The wind slows. The temperature drops just enough for the air to thicken. The sounds of insects begin to rise, faint at first, then steady. It's the kind of calm that feels ancient, the kind that has existed in some form for as long as the planet has cooled after fire. Somewhere beneath that lake, in the layers of hardened magma and trapped gas, the Earth's heat still pulses. It's the same heat that powers every volcano, every geyser, every tectonic drift. It's the planet's heartbeat, slow and deep. That heartbeat doesn't stop, even when the surface seems silent. It's what keeps everything moving, what ensures that nothing stays frozen in place. The same energy that once nearly destroyed life now sustains it. The warmth beneath our feet is not danger, it's continuity. The quiet isn't final because the Earth doesn't do endings. It moves in cycles, not lines. What feels like conclusion to us is simply transition. The calm after Toba's storm became the foundation for new life, just as the calm we live in now will one day give way to another kind of change. The planet doesn't rush, it doesn't forget, it only continues. When we look at the Earth today, it's easy to think of it as something separate from ourselves, a landscape we live on rather than a system we live within. But the truth is simpler. We're made of the same materials, driven by the same energy, shaped by the same forces. The ash that once fell has become part of us. The planet's memory and our own are the same memory written in different forms. The quiet after the storm is that recognition that we are not observers but participants in the same process. The Earth isn't behind us or ahead of us, it's beneath us, around us, within us. Every heartbeat mirrors its rhythm, every breath follows its pace. To live here is to be part of its endless act of balance. And as the night settles over the lake, the air cooling, the water stilling, the world enters one of those moments of perfect equilibrium. The sky above deepens in colour, the horizon fades, the stars begin to appear, one after another, steady and distant. Somewhere in the dark beneath the lake, the magma stirs slowly, not in threat, but in patience. The planet holds its silence, knowing it will speak again when the time comes. For now, there is only calm, the same calm that followed the fire, the same calm that will come after every storm. The Earth rests, but it never stops moving. The quiet isn't the end of the story, it's the pause between one breath and the next, the soft space where everything waits to begin again. And in that pause, the planet, the people, and the passing of time are all the same thing, one unbroken continuity, one long exhale after an age of fire.